This conference will now be recorded. This conference will now be recorded.
All right, folks, welcome to day 9 in our Google Cloud Architect training. So last week we had discussed about managed instance group where we saw by ourselves how auto scaling works, scaling up and scaling down. Both the concepts we learned by doing a small demonstration, which gave us an idea how in real implementation people do the stuffs. So that gave us an idea. And there were a couple of stuffs which I told we will discuss it in today's class. More about the host and path mapping. We did not discuss much because we did not had much time there last time, so I wanted to put it to today's class. And what is all about unmanaged instance group, we'll discuss about those things. That should conclude most of the stuffs in our compute engine, and we should go to our Kubernetes concepts today itself. All right, so the stuff which we did not see last week. So this is an important thing, and we are going to revisit this in our networking class one more time. So when we were creating our load balancer last week, L7 load balancer, there was a second set of configuration. The first configuration was create a backend. So let me just do this quickly for you to recollect what I'm talking about. So if I just go to my
Oh
load
shit.
balancer, network services, load balancing, create a load balancer, L7, layer 7, the topmost layer and the smartest layer which you get when it comes to load balancing. So the option which we gave was we gave a name, LB demo, backend we configured, we had a backend service, we configured that, and the host and path rule, we left it as default. We did not even touch it. What is this basically is what I wanted to share today. So you can have multiple host and path rules. Basically what this does is this is something very unique in layer 7 only, because in layer 7 you will have lots of more information, so it gets easy to route it properly. So you may have a slash url, something like um, if you have something like www.myapp.com, this is my domain, and if anybody types www.myapp.com/APIs or static, let me just make it static. So all static contents, videos, images, JavaScript, CSS, all those things, I can serve this from one specific backend, which could be possibly a storage bucket. I can have another rule which I can use, www.myapp.com/Asia. So if the URL is like this, Asia, I will serve it with some specific content for Asian customers. So I can do all these kinds of stuffs easily with host and um, path rules here. Similarly, slash API, slash images, what you want, you can serve it. So if it's slash API in this diagram, it is served from a instance group. If it is slash images, it's going to be served from a bucket. So uh, and you also have few other stuffs called as network endpoint group, which we'll try to see it more in our networking class. So this is your host and path rules, which is only available in layer 7. I'm emphasizing this again and again. This is only available in layer 7. So when we look into Kubernetes class today, right, we will also again use a load balancer, but that load balancer would be layer 4. So TCP layer. So you will see this feature is not going to be there. So if you want to use this host and path rule, you have to use something called as ingress. We'll talk about that again. So this is an important stuff. So based on the URL you can route it to a different backend. So the backend could be basically the stuffs which we know as of now, could be either, if I just go to my backend, the backend could be a backend service. Under backend service, it can be a instance group. We don't know about other things. We'll look into that at a later point of time. So instance group is one of the possible backends. And you never see a virtual machine here, folks. Whenever you are looking into a Google Cloud, a load balancer, at least Google Cloud global load balancer, you cannot attach a load balancer to a virtual machine. Very important from the exam. I'm just going to take a small screenshot of this so that we don't miss it out, and I'll put it. Um, these are very small concepts, but people make mistakes during the exam. Okay, I have to, how do I take this? Okay, I'll take a print screen. Uh, Load balancer can be attached to a instance group only, not to anything else. So let me just take this one. And we are doing it live. So questions can come easily, like load balancer is not working. You want to attach directly a virtual machine. That answer is wrong, because you have to use only a instance group. Nowhere in the drop down you get an option for load balancer. Sorry, for instance, individual instance. It's always an instance group. So this is very, very important. Let me just add this in our exam tip. Load balancer can be attached to an instance group and not to an so not to an individual. Hope this makes sense, folks. Individual VM GCE instance. It's not possible. It's not possible. Always you have to have an instance group. It can be managed or it could be unmanaged, which we are going to see in the next few minutes.
I think not was missing there.
So this is something which we missed. So I wanted to share this part, and this is going to be available for any L7 load balancer. So something which we talked about these things we talked. So I'm just going to skip, scale up, scale in, all those things, scale in, scale down, all those things we had seen. We had stopped our stuff at this project exceeded stuff, which we also saw in our this thing. I also heard from a couple of you that you also tried it. I was really happy to know that you tried it, and I would strongly suggest others to also try it. If you have tried it, it's good. If you have not tried it, I would strongly suggest you to spend some time on it. That's going to be really helpful. So questions on this kind of stuffs also can come. So um, scaling is working fine, but all of a sudden it's not working. Possibly you have exceeded your quota. So something which we saw in our demo itself. Now let me just show you what is unmanaged instance group, and then we'll jump into the next concept in cloud compute engine. So when we created last time the instance group, the UI keeps changing, folks. So now they have grouped it into virtual machines, instance groups, package like VM package manager, all those things. So just keep an update, keep looking into the console, so that even last week to this week, the content would have been changed, the interface basically. So instance groups, you can create three types of instance group. One which we saw was MIG, managed instance group, and that too it was stateless because we have not looked into database. So if you want to look into, if you want to preserve the state, all those things, then stateful MIG is going to be a good choice. And the last option, which we were supposed to look last Sunday itself, was unmanaged instance group. So if you look into this here itself, uh, most of the time The content which is there in the console itself will help us some good information. So tool tips, all those things. So if you just look into here, managed instance group, stateless, what and all they support. Auto scaling, we know what is that now. Auto healing, we know that. So if the VM is not responding, it's going to just dismantle that and it's going to create a new one with instance template. Instance template behind the scene uses a image. So auto updating, multi-zone deployment we saw, load balancing we saw. So these are all the supported features when it comes to managed instance group stateless. When it comes to stateful, it's a new feature. I have not explored it much. It's basically for databases. So where you can basically use auto healing and updating capability. So auto scaling is not a feature here. Okay, so you cannot add more databases on the fly. That is not possible. You can do load balancing, multi-zone deployment is possible. And the last option which you have is unmanaged instance group. um, I've never used this, like I have never seen this term used by Googlers or in Google. UMIG. So but we can use it if we want. Unmanaged instance group. And what does this provide? It's basically load balancing only. Now you may ask, then if it's only load balancing, why should I use this? I would better use something like managed instance group stateless or stateful. So there are situations where unmanaged instance group can come into picture. So let me just explain you with a small story here so that it can get this thing. So the last thing which we celebrated as a festival or a kind of a event was Valentine's Day, for example. So that was in February. So let's take Valentine's Day itself as an example here. So you have a website which sells some greetings, some kind of a gift material during this time. So your website becomes really it receives huge amount of traffic during this period. After this period, not much basically. So that is what, or wherever this kind of occasion comes, your website becomes slightly popular. So that's the use case. And your website is your organization's website. So let's call this as, it's called as myapp.com. This is currently in on-prem. On-prem. So currently it is in on-prem. Let's go back in time. So you had a plan in 2021. You are going to launch this website, and it's going to launch on February 14th. All those things. Now you were not there. The organization was there, assume. The team has started working on it and they have come up with an architecture, all those things, with the budget, with the constraints of the budget, all those things. They have gone in on-prem, so with something like 16 vCPU. Good that they are using already virtualization there, and they have used 32 GB of RAM. This is machine one. uh, Machine one. This is a configuration, and you have gone live. You have gone live maybe last something like July or something. So you have gone live, everything has gone good, so things are going fine. Now again some event comes, and the website is becoming very popular day by day. So it is 16 vCPU. It's becoming popular day by day, and but the experience, everything is good, but one complaint which you get from the customer is the response. So sometimes the website is slow, latency is high, is what you get. So when you in the sense the organization checks it and they understand it, the capacity of this virtual machine is small. So what they do is they add a new virtual machine 2, but this time there's no enough budget in the organization, so we are going to use 8 vCPU only. So they are going to give you 8 vCPU, 16 GB RAM. Now two machines are there, so they have to do something extra, right? So what you are going to do is you're going to add a load balancer. So if you search for load balancer in internet, you'll get lots of load balancer in on-premise. One of the popular one is FY load balancer. So, or any other load balancer in on-prem which works. Basically, these are hardware-based load balancer. So you have to do some pre-warming, all those things. Only then they are going to handle the load properly. Good. Now things are working fine, and again the website is becoming very popular day by day. But uh, the organization is not interested in investing much on this website for some reason. So we don't know the reason. So this keeps on going. Again, there's a request. So somehow they get an approval. People who have worked in on-prem would have understood this, because to get a new machine, right, it has to go to a procurement process, all those things. It takes time. So with all the fight, all those things, somehow they have got a, configuration which is like this. That's it. Uh, so things are going on, but it's not that popular. Uh, Sorry, it's not, you're not getting enough capacity as you are as expected. Somehow you're getting some basic stuff. Now it's time for you to enter the organization. You enter the organization, you join the organization as a cloud architect, GCP cloud architect. So now you hear the story from the manager or from the colleagues. This is what is going with this app. Now with your knowledge, uh, and you cannot directly say let's go with MIG, let's go to GCP, all those things. So with your knowledge, what you'll say is let's do a left hand shift, meaning we already have 3 virtual machines running this myapp.com. Why don't we do a left hand shift? So easy, less risky, because this could be your first project and you don't want to take any huge risk. You don't know the organization, all those things. So do a lift and shift, meaning there are 3 VMs. You have these configurations. Create 3 VMs exactly there and do a migration. There are tools for that. We'll talk about that in our 9th module. So you have brought it into GCP. So there are VM1, VM2, VM3. So you will definitely get a configuration exactly for what they want. So it could be something like N2 series is what you are going to use. Basically, let's do N2 series. You have, it should be N2 standard 16, right? Let me just see what's the combination I can get. I should have one option. So if I just see quickly, what is that 16 VCPU I can get, in which series I can get. Even if I don't get it, I can go with custom machine type, that is possible. But just checking whether there's any predefined configuration. So if there's a predefined machine, I would prefer to use that instead of making it more complicated. And if you already have a predefined one and you wanted something, do I have it? If I don't have it, I'll use a predefined custom 1632. Okay, it is not there. I'll just use a custom one. So I'll just use a custom one. So some custom, I'll just mention it as N2 custom. So you find out the machine type. That should not be a problem. So find out those things. You are there in GCP. Now what you do is simply add them to a unmanaged instance group, an individual virtual machine. So I remember last time somebody asked, if I'm not wrong, Kumar asked this, like, is it mandatory to always have a instance template and do it? So I told it's not required. So if you are using an unmanaged instance group, you don't need it. So you create virtual machines. Simple. How it was in on-prem, you bring it the same way in GCP. Now, once all those 3 VMs are there, what you do is basically you create a unmanaged instance group and attach a load balancer. Global load balancer. Done. You're all done, and you should be able to do as it works. Now then show them how it works. They'll really like the feature. So easy. And if they wanted to add more servers, it's going to be much easier than on-prem, because in on-prem you have to go through a procurement process, but in GCP it's going to be on demand. You can just go and add it and you are going to get a bill in the next month. So if you want, You can add more VMs if you want, and your performance issue can be fixed. And slowly you can start saying, instead of this approach, why don't we go to managed instance group? So that's what you can do easily. So it's very easy. Let me just quickly show you how you can have one virtual machine and add it to a instance group, which is going to be unmanaged instance group, and then how can you attach it to a load balancer quickly. So this is where usually unmanaged instance group is going to be used for on-prem to GCP migration, where you want only load balancing. And if you have heard this, it will make more sense there. So in on-prem, you don't have the secret sauce of auto scaling. This secret sauce is only available in cloud. Cloud providers only do this. So in on-prem, uh, you'll not be able to do this auto scaling capability there. So let me just quickly do this. I'll call this as VM1. I'm just going to use F1. F1 should be good enough. That's it. Uh, just an Apache web server, nothing else. So just an Apache web server. I'll just put a startup script, apt update. You don't need a sudo command because the startup script runs as a root user. So -y Apache 2. That's it. A VM created. Something like assume this has been migrated to your GCP environment. Now, how can I do it? And we know we cannot attach a load balancer to a virtual machine. So if you have this kind of a requirement, a load balancer is required and quickly you wanted to do, you can also do this. So I usually do this for some quick proof of concept. Usually VM is there. If I just click on it, it's going to show me, it's going to work. Now, what I do basically is go to, now I don't have any templates. Let me see whether I have any templates. Okay, I have one. Let me just delete this. So I have no templates here. Now, what I'll do is I'll go to my instance groups. Now, I'm going to create a use an unmanaged instance group. And I'll show you how you can attach this existing VM. So instance groups, go to my unmanaged instance group, give a name something like UMIG Asia. Done. And if I select some other zone, I will not see any VM. So this is the screen, folks. This is the screen which you should be focusing on. Because I have created the VM in A zone, you will have an option of that VM coming here. So you have to select that specific one. Basically, it's going to be multi, I would say, you can add n number of MIGs, unmanaged instance groups, but you have to select those things. Done. I have it. And if you have more VMs in A zone, you can add it. That's it. That's the command. That's the option to create your unmanaged instance group, folks. Now I want to see the command line equivalent of it. Let's just look into it. Gcloud compute instance group unmanaged. You see this? It was managed previously. This is unmanaged. Create in that zone, and you are adding an instance, an existing instance, and it is VM1. That's it. So let me just do this. Click create. People don't use unmanaged instance group in cloud heavily. It's only used for migration. Once you are in here, slowly migrate it into MIG. So in the initial stage, this could be really helpful. And you don't see auto scaling option, nothing. It's unmanaged basically. Now, since you have a instance group, forget it whether it's managed or unmanaged, you have an instance group. Meaning if I go to my load balancer, I should be able to attach this simply. let's just go and look into our networking, network services, load balancing. Create a load balancer. Same stuff. Uh, Demo unmanaged instance group. Backend. If I select the backend service, you will have it in the dropdown. You will see that unmanaged instance group coming. So this is a easy way to attach a load balancer. So the big advantage of load balancer is that IP is an anycast IP. So uh, one single IP across the world. So you don't need to have multiple IPs there. So that's one big advantage there, and you can leverage that with the help of your instance group. There are a few other options which we'll explore as we progress. Okay. So that's your unmanaged instance group, the use of it. Why do we use it? So it's usually used in on-prem to GCP migration. Later, it's going to be converted into MIG, basically. So any questions on this, folks? Any questions, thoughts? Folks, I'm still audible, right? I see silence there. Yeah, thank you. All right, so if there's no questions, let's move on. Let's move on to the next part. But before this, let me just go and delete my this thing. So make it as a practice so that you don't forget it. So the difference between unmanaged and managed, simple. So in unmanaged, you only get load balancing. In managed, you get auto scaling, auto healing, or auto upgrade, multiple zone deployment. You get all those things. The screen itself was helping us to show those features there, Vijay. So that's the difference. Uh, any dissimilar? Yes, you can also add. Yeah, thank you, Anil. Anil B. So you can add dissimilar VMs basically. So when it comes to maybe I can just do that. I'll just show you one more. I can add dissimilar VMs. So that was the whole thing which we were seeing. So in managed instance group, it has to be identical because you are going to create it via a template. So here it is dissimilar stuffs basically. So that's an important one. Thanks, Anil, for highlighting that. So if I just add one more, uh, use case is when you do an on-prem to GCP migration, because in on-prem you'll have dissimilar some systems, and you want to use that itself in GCP with a load balancer. Unmanaged instance group is a good use case. Not sure whether you joined in the middle, Vijay. So we started with that. So that's where we started our story here. So on-prem you have, how do you do it? So this is one possible use case which I can think of. So on-prem to GCP, that's where it comes. But if it comes totally, you are building something totally in cloud, I don't see a, a good fit for anything else, except you want a load balancer quickly to be done. You can use that basically quickly. That's what you can do it. No problem. So let me just add one more dissimilar VM, something like E2 series. Call this as 2. It is E2 series. Let me just add this and show you how I can add this to my instance group. So I have two dissimilar VMs. So let me just machine types. One is micro, the other one is going to be some E2 series. Let's just wait for this to come up. Different series as what we saw in our notes. If I just go to my instance group, click on this, edit the group. You want to add a new instance, add it. So it's going to be so easy for that team who were working on this stuff. New VMs needs to be added, so easy, they can come and add key easily. But that auto scaling feature is not there. But at least for them, provisioning a VM itself was difficult because of the constraints which they had. But it's going to be so easy because of unmanaged instance group for them. So that's how it's going to work. Dissimilar VMs can be easily added. So let me just delete this group. I don't need it anymore. And I'll also delete the VM also. So that's a small thing which was pending last week because we were running out of time. I told we'll do it today. So now what we'll do is we will go to the next part about some optimization. So this is a very cool feature which you get in GCP. I guess in other cloud providers also you get it. I have seen something like this in Azure, but not sure whether I have seen it in AWS. So what is this is basically if you're running a VM and assume you from on-prem to GCP itself. In on-prem, if it was something like 16 vCPU, 32 GB of RAM, you migrated as is because you don't know much information and they have not even shared the utilization of how it is working, but they are just asked to do a proof of concept, do this migration. What you will do basically, apple to apple kind of a stuff migration is what you are going to do, lift and shift. You will just try to provision a 16 vCPU, 32 GB of RAM in GCP and run that, create that virtual machine, make those migration stuffs. But later, couple of days after, Google is going to give you some recommendation automatically. This is where you can see basically machine learning in action. So Google is going to capture all the metrics about the CPU, memory, all those things, the utilization, and it's going to give you a sizing recommendation automatically. For example, in this case, my current machine type is 4 vCPU, 15 GB of RAM. Basically, N1 standard 4 is what I understand. Now, yeah, that is the one. Now it is giving a recommendation that it is underutilized by changing the machine type to 2 vCPU 8.25 GB, which is a custom machine type. You can save up to, sorry, you can save up to $87 per month. So this is a very cool recommendation. So what I would suggest is uh, this recommendation, you should not apply this if it's 2 days old recommendation. Basically, you create a VM today and on Monday or Tuesday when you're looking at it may not be a appropriate one. I would suggest to leave the system running for at least a week so that you will have the complete picture. The machine learning will also get more data and it can give you a better recommendation. So that's a good one, I would say. So you get underutilization also, overutilization stuff also. Maybe if you overutilize your VM, it's going to give you a uh, recommendation, please increase the machine type. Otherwise, there's a chance that the machine may hang or crash. It can happen. So both the stuffs, underutilization or overutilization, both it's going to show. And if you are interested, you can just click on this button. It's going to pop up the screen, resize the instance and do it. So you need to change the machine type. Basically, it's going to do automatically the machine type there. So I can just share one of my real experience with it. So let me just show you that in a video. uh, I have a couple of videos on this resizing. um, I'll also share my real own experience, the blunders which I did. uh, so if I just go to my YouTube, uh, so when I was working in a service-based organization, this was a dev environment actually. So it was a dev environment and I was working in offshore. So there are two things. Okay. There are two videos. If you search for sizing, you will come to know. So one of the video is basically which shows it is undersized. So it's one of the shortest video which I have in my channel, 23 seconds. Basically, it shows something like this. Instance builder is underutilized. You can save $15. So if I click on this, it's going to show currently it is this one, you can change it to this one, and by doing which you will be able to save some good amount of dollars, $15 per month. Now if you want to apply the changes, you just click on apply. If you want to dismiss it, you dismiss this. Now a question to you people. So if I just go back to this, take a look at this VM. So it has internal IP, external IP. It is in Mumbai A zone. Now, if I do this apply, what and all is going to happen, folks? What are the stuffs which is going to change? Just wanted to hear from you. Then I'll share my own experience. So machine type needs to be changed. That's what is the recommendation. What will happen when you do this? Basically, how do you do it? By just clicking on apply, it's going to do it. But what's going to happen behind the scene? Any thoughts? That was a good one, Anil. So if you can slightly elaborate what you are talking, there are two things. You need to be little this thing. Yes, Anil Kumar, both Anil gave the answer. Uh, so others, so please change it to your this thing. Instead of everyone, make it to private chat so that I can only see it. Custom machine type is going to be chosen. Yes, custom machine type is going to be selected. It's not always custom. In this, actually, it is showing custom. So what's going to happen is basically now this is a huge number. Like this, maybe 15 is a small number, but if you see in my slide, $87. So $87. So um, this is what I was doing actually, at least in my beginning of the career. So I have to get a good name in front of the customer, right? Proactively, I used to do a couple of stuffs. So, and it was in a dev environment. So I used to see something like this kind of a recommendation. I used to take the first time when I saw, I thought, let me impress the customer proactively. So an individual usually try to do this. So I thought I'll also do it. So what I did was, I was not aware of this. So when I was doing this, so I just went out, I just took a screenshot before, added it in my Outlook, kept it ready, went and so easily applied it, and it applied the changes, and I sent a mail. I have saved this much of dollars. So I thought I'll get a good name. So I did it. Um, to be very frank, I did not get any response from the customer. So that's the thing. But what happened was, as most of you mentioned, the external IP address, and it was fortunately a dev environment, so not much issues occurred. The IP address was an ephemeral IP address. So what happened was the IP address changed, and I started getting messages from the developer saying that I'm not able to connect to this Windows. It was a Windows machine, so there was some load balancing testing they were doing. They were saying I'm not able to connect it. What happened? Then I saw, because I had taken a screenshot, right? Then I came to know that the IP address has changed. So the IP address is changed, and because of which they are not able to connect. So I just shared them the new updated IP, and I had to share them, tell some story that maybe because of some issue I had to restart it. That's the reason IP address changed. So the learning which I learned from this was, whenever you see this kind of a recommendation, right, you'll be tempted to restart it, but just check whether it's the right time to restart it. Whether it's a dev environment, a non or a production environment. In production, you cannot do it because there's going to be a downtime. We have seen that to change a machine type, you have to restart it. So whether it is appropriate to do it in a production environment, that's one thing. The second important thing is the IP address. So what you should do basically is go and make this IP address static first, then go and apply it. If you really want to apply it, go and do that. So after that blunder which I did, I started still applying this kind of changes regularly, and I used to send mail to the customer. Once I got a appreciation, not first time, at some later point I got an appreciation that good job. That's it. What I started doing is, whenever I see this kind of a recommendation, I used to go and make it static. Now you may ask whether static IP is going to charge us or not. So if it's an external IP address, whether it is ephemeral or static, the cost is the same. So you don't have any issues there. So the only thing is that when you delete the VM, the external IP address should be released. If you don't release it, you're going to incur heavy cost. Per hour costing is going to be there. But if it's being used by a virtual machine, whether it's static or ephemeral, the cost is same. So this is an important thing. So if you want to apply this kind of a stuff for any existing stuff, I would suggest use basically make the IP static. So let me just show you one more video there where let me just um, let me just move this out. So this one is basically, it's not always saving your cost. Google also sometimes gives you a recommendation. Here, if you see here, the machine is overutilized. I have used only N1 standard, but I'm extensively utilizing it. So Google gives me a recommendation is increase your performance. It's not saving cost, but it's increasing your performance. So it is saying, if I just click on this recommendation, uh, so so it gives both. Basically, it's not always saving the stuff. So if I click on it, instead of N1 standard, it's going to say better have something better. So if I click on this, yeah, 2 vCPU, 5.5 GB, if you make it, it's going to be better is what it indicates. But again, make sure the external IP address is made static. We'll talk about more about external IP address in our networking class and how what is the cost, all those things. But a small tip is make the IP address static. So that's a small stuff. My own implementations, my own blunders, which I did, just thought of sharing it with you folks. So that's on the sizing recommendation. So this is again could be a really good uh, option for cost optimization. So this works for virtual machines and for Kubernetes, which we are going to talk in today's class. So that's the end of our GCE module, the sub module. So we'll jump into Kubernetes. But before we wind up this, when should you use your virtual machine? Basically, so whenever you have any use cases, I'll come to a question. There's a question once I finish this slide. So whenever you have a lift and shift kind of a requirement, basically you can use virtual machines, meaning something is there in on-prem and you want to bring it to GCP as is without doing any code change, exact carbon copy kind of a stuff. You can use this. It's going to be an easy fit. And lift and shifts are one of the best ways of starting your migration, on-prem to GCP migration. So if you need tensor processing unit, so this is something very specific to Google. So if you want TPUs, GPUs, local SSDs, then again virtual machine could be a good choice. Or if you have a specific requirement, you want to run MongoDB, you want to run some deep machine learning capabilities with some specific tools, or Linux, Apache, MySQL, PHP, LAMP stack, you can go with marketplace, which basically installs everything on a virtual machine. So if you have such kind of a requirement, you can go with virtual machines. If your SLA, service level agreement for provisioning a resource, is less than 30 seconds, virtual machine is a good choice. And later we will see this SLA may drop to few milliseconds. At that time, we have different products in GCP called as App Engine, Cloud Run, and all. We will look into that. But if it's like this high level, I would say virtual machine is a good choice. If you have a specific OS requirement, Kali Linux, which is usually used for penetration testing, you don't get this in normally in compute engine, but you can bring a image from on-prem and have it, or you can use, there are methods where you can export it into Google Cloud Storage. From there you can create a virtual machine. So possibilities are there. So whenever you have a specific OS, maybe in on-prem you would have created a specific golden image which you are using continuously. The same image is what you wanted to use it, and that image is not available in GCP, so you can definitely do that. The last part is if you want to run a single container. We don't know what is container in detail. We will talk about this line more in detail in our GKE part. So these are the cases where you should use compute engine and use this as your fallback option, folks. If nothing works, not all the modern options works. They call serverless, they call as container based applications. If none of those things works, you come to your virtual machine. Simple. With a virtual machine, most of the things should be possible. So most of the things should be possible there. So there are a couple of questions here. So first question, let me answer. Um, will there be charges for ephemeral and static IP in will the charges for ephemeral and static IP same in use? Yes, if it's a external IP address, if it's ephemeral or static, the cost is the same. No difference. It's the same cost. Maybe I can just quickly show you that so that you have a better idea. So when it comes to pricing calculator is a good fit. There are a few more questions. Let me answer it. So go to pricing calculator. Virtual machines. This is one virtual machine. One virtual machine is what I want. And I'll make it as N1 standard 1. And they have a specific section. Let's make it in US Central. They have a section instance using ephemeral IP, instance using static IP. Let me just make it as ephemeral IP first and add to the estimate. So when I add to the estimate, you come to know for an ephemeral IP address, public IP address, it's $2.29. So that's the cost. Now let me make this static and show you this thing. What's going to be the cost? So I'll make this empty and use a static IP, then add it. It's going to be the same dollars, same cost. So if it's public IP, whether it's static or ephemeral, does not make any difference. But the only thing is that the moment you release that VM, you should delete your external IP address. Otherwise, you will have a huge cost there. Hope that answers your question, Anil B. There's one more question from Anil Kumar. When you say lift and shift, are you going to use Velostrata here? So different tools are possible. So one of the option is Velostrata, which is an acquisition which Google did. Now they call it as migrate for compute engine. That's one option. Or if you have any other tools, you can also use it. So basically, what I wanted to emphasize here with lift and shift is do any don't do any changes to your existing application in on-prem. So you want to bring it as is there without doing any changes. Basically in on-prem, most of the time it's going to be on a virtual machine, right? If you want to bring that, a GCE is going to be a good fit there. What is a kernel? Basically a OS, operating system. So what's the kernel what you wanted to use, whether it's a Linux kernel or a Windows kernel? What is that? That's the option. So what is the specific OS you are going to use, Kumar? So hope I have answered those questions, folks. So these are the cases where you are going to use virtual machine. And there are scenarios which you will see throughout the class where you will feel virtual machine could be a fit in this case. Some specific scenarios which will come where your existing products in GCP may not be a fit. You have to fall back here. This is your fallback option. I would say like a small analogy is if nothing works, you go back and discuss with your mother or your father or with your spouse, right? uh, None of the options works, you go back to them, right? It is like this. So if none of the option works, you go back to your virtual machine. Simple. So that's something on GCE, folks. Now let me just stop here for any questions. So this is our first sub module in compute engine. Now we will jump into the next part. So in our ladder, infrastructure as a service was compute engine. Now we are going slightly up the ladder where we are going to look into container as a service. So first of all, before we go into Kubernetes, GKE, all those things, we need to understand what is container, why GKE came, all those things. Virtual machine, everybody understands. That's what we would have used uh, heavily in on-premise. But containers, not many, but now many people have started using it. So we will go through a history, understand it, and then come to GKE. Maybe we will start GKE only tomorrow. Today we will learn container concepts, basically to bring everybody to the same page, to the same level. We will look into those concepts. But before that, any questions on compute engine, folks? GCE, of what you have seen so far. All right, there's no questions. Fine. So maybe 10 minutes I'll talk about the introduction part of this. And okay, uh, is all projects uses load balancer? Depending on the requirement. So it's not always required that you need to have a load balancer. So say for example, if I have serverless products like App Engine, we'll talk about that maybe next Saturday. At that time, you don't need a load balancer. So you may have a built-in load balancer there. Not always. And if it is not a web-facing application, why do you need a load balancer? So you don't need to have it. Basically, it's not always mandatory to have a load balancer. It's basically based on your requirement. If you want an exposure to the outside world, you create a load balancer. And in load balancer itself, you get different flavors: global load balancer, regional load balancer, all those things. Again, if your website needs to be available across the world, then you go with global load balancer. If it's only in one specific country, then you can go with a regional load balancer also. It's not always mandatory. So, and if my project is all something related to some warehouse, machine learning stuffs, then I may not need even load balancer itself. I may not need even networking in such cases there. So if I'm using some serverless products like BigQuery, which is basically on data analytics kind of stuff, I may not even come to virtual machines or anything. I'll just focus on that. So it's not always required, Kumar. Any other questions, folks? All other previous questions, hope it is clear, folks. Um, the external IP, which is static or ephemeral, it's going to be same. I showed you that live in the this thing itself. To Anil Kumar's this thing, it should be uh, using any tools. Basically, you don't do any changes to your existing app. Bring it as is to GCP. That is where I wanted to mention by left and shift there. When I click on the external IP address in the VM, it gives me a message. It gives the site is not reachable. Okay. What happens usually is if you just click on the virtual, there should be something running in that virtual machine, Mangesh. So you create a virtual machine. Yes, with all the default setting, you will have an external IP address. So what you have done, I'll just show you. So if I have a virtual machine, let me just wait for this to come up. Slowness, I have a back. So if I just go to my virtual machine, started thinking like a architect. So this is my another machine, so where I can easily show this. So let me create a virtual machine. So the difference between my machine and a machine which is provisioned in GCP itself. So if I just create basically a virtual machine, that's it. With all the default setting, what's going to happen basically is it's going to give me an internal IP address, it's going to give me an external IP address, but nothing is running in it. So no apps are running in it. So if you just click on it, it's going to show site is not reachable. There should be some application which should listen on port 80 basically. So that is the error message which you are getting. So if I just refresh the screen, I have an IP. So it does not mean I can use it in web. So if I just go put it here, it's going to show nothing is, there's no app which is listening on port 80. So you have to have an app running on port 80 and you have to open firewall rule. Only then you will be able to get a response. So Git will not have, okay, I have installed it, may need to have installed, yes, Apache or Nginx, something you install it so that port 80 is made available, basically. Hope that answers your question, Mangesh. And you will get this hyperlink only if you have turned on the firewall rule. So that's a small user interface capability which Google has done. So, but it's not necessary that you always need to turn on the firewall rule in the console. You can do different ways, basically. All right. Hope I have answered it. Good. Now what we'll do is basically, anyway, it's an hour. So we'll take a 10 minutes break, folks. Once we come back, we will look into GKE. What is GKE in 4 words? If I were to explain, this is taken again from GCP in 4 words. That from that first day PDF which I showed, which is created by Google team. So it is managed Kubernetes and containers. What is containers? What is Kubernetes? We don't know, but we'll try to understand it in today's class. You get a equivalent of this in other cloud providers also. EKS, Elastic Kubernetes Service. In Azure, you have AKS, Azure Kubernetes Service. So the underlying technology is Kubernetes, which is open sourced. So this is really a cool product, and most of the organizations these days are behind this. The reason is because it is cloud agnostic solution. So it can work in any cloud, AWS, GCP, Azure, and even in Oracle Cloud, Alibaba Cloud, you get this flavor easily available. So, but we'll not directly jump into Kubernetes concept. We'll go at least 3 decades back and see how people were doing like how they were doing computing, how they were running applications. Slowly we'll understand there the pain points, and then maybe tomorrow's class we'll look into Kubernetes. Okay, so take a 10 minutes break, folks. Once you're back from the break, into container concepts first of all. Okay, let me stop the recording.
This conference will now be recorded.
Okay, so the next submodule which we are going to look into in our compute option is GKE, Google Kubernetes Engine, GKE in short. So you get an equivalent of this in other cloud also easily, and we'll talk more about that in detail. But before we go to Kubernetes, why Kubernetes came into picture, we need to understand it. So to understand that, we have to go at least 3 decades back in time and understand how people were running their various compute options, maybe running a simple web server and a web application, how people were doing it. Let's look into it. This may look very basic for people who are hardcore infrastructure folks, but for people who come from software background, it's going to be at least to give some idea there. So dedicated servers, you purchase a hardware from a hardware provider like HP, EMC, Dell kind of stuffs. So you will have a hardware, or if you have never looked into a bare metal, just treat as your laptop, for example, simple. So it's a bare metal. So on top of that, you have a kernel, a specific operating system. It could be Windows, Linux, Solaris, whatever it is. Then on top of that, you will install all the necessary dependencies. If it's going to be a Java based application, you will install Java. If you are going to run a Python, you are going to install Python specific modules, and then your code basically is going to get executed. So this is how people used to do provisioning, used to run applications at least 3 decades back. Uh, Straightforward option, it was working fine. But one of the biggest drawback of dedicated server was the entire server is used for one application. That was the biggest problem. Now, if you take this slide which you're seeing as an application itself, an application which has the banner which is blue in color and which has some text, all those things. And if I were to have a newer version, like I don't want a blue color in my banner, but I want an orange color. If this is my website, assume treat this as my website, this slide as my website. And if I were to change it to orange color, and before I release it to the production, I wanted to check it once. If I were to do it, if I am going with dedicated server, I have to purchase a new dedicated server, meaning my focus switches from implementation deployment to procurement. So I have to go back to the procurement team, raise a request, the PO should be approved, all those things, the purchase order should be approved, all those things. So it's going to take a totally a different route. So that is where at that time organizations like VMware and all started providing some different solutions called as virtual machines, where it was exactly the same concept, but on top of your bare metals, they install a software, a system level software called as hypervisor. So, which is going to basically virtualize your hardware. So by that way, I can use the system, I can slice and dice my hardware and use specific, maybe if my hardware is very powerful, something like 16 cores, it's not VCP folks, cores. 16 cores and 32 GB RAM. So I can run a hypervisor on top of it. So it's basically a system software. That's it. So on top of your hardware, you install this, then you can create multiple machines. So these are your virtual machines. Now I use the same hardware and fully use it by creating multiple virtual machines. So I can have a new kernel for this. Assume this is my production version. I have the kernel, the dependency for version 1, the application code. Now, if I wanted to change this application to have an orange banner, what I will do, I'll create version 2, and I quickly on the same hardware, I can create a new virtual machine. Simple. Create a new virtual machine and try everything is working fine. If everything is working fine, I will productionize it. So now I don't need to switch to a new dedicated hardware. I can still use my existing hardware, assuming the hardware is powerful enough. So usually it's going to be powerful enough. Now with the hypervisor, we are able to use slice and dice it basically. So this is where people started moving towards virtualization. One of the organizations who was very much prominent in this was VMware basically. So they provided solutions like vSphere kind of stuffs, and you have some open source versions also available like KVM, Zen. Microsoft has something called as Hyper-V. So these are all your hypervisors. And when it comes to hypervisors, there are two types of hypervisors. One is type 1, the other one is type 2. Type 1 is something which you install directly on your bare metal. Type 2 is something which we would have used in our laptop, because we have the laptop, we have a specific OS, Windows, Linux, whatever it is, Mac. So on top of that, we would have installed something like VirtualBox, VMware Player. Those are all type 2 hypervisors. They don't leverage the hardware directly. Type 1, they leverage the hardware fully. So production grade, they prefer to use type 1 hypervisor. So moved from bare metals to virtualization. Awesome. We are able to have more deployments easily instead of relying on procurement team to purchase every time a new one. So that's all good. But later people started seeing it's basically evolution, right? So you find some issues, you go to a next set. From that you find some more issues, you find a better solution. So for decades people started using virtualization. Even today people use virtualization to a great extent. But one of the big problem with virtualization is, at least in this context, to application code testing, all those things, my application 1 is different, my application 2 is different, my dependencies for application for the version 1 of my application is different, and for the second version it is different. But what is common is the OS, the kernel. So this is going to become a problem, meaning maybe my requirement was very small, changing the banner from blue to orange. To just check this out, should I have to have a heavy kernel? Usually your OS is going to be of how much size? 1 GB. So meaning my virtual machine should have at least good amount of space, memory allocated to have this. So this kernel or the OS itself becomes an overhead when you are doing to do more like this kind of a deployment. Small versions, want to check it, all those things. So that's where people felt the kernel is becoming the footprint, the storage footprint for a kernel is going to be huge, and it's not easily portable. And if you have a kernel, definitely you need to boot it. So there's going to be a boot time to check all those things. People felt this is going to become like, it's going to be a overhead. So that's where people started looking for something better than virtualization. So one of the solution which few of them were able to figure it out was called as containers. So what is this containers? So if you see dedicated, everything is on one single dedicated server. That's it. Virtualization, you use bare metal plus your hypervisor. So virtualize it, you can have multiple VMs. Now, slightly an advanced thing which people started looking into, like Docker, all those things, and Google was using this very heavily behind the scenes. Uh, Along with the kernel, they install a software. Again, a system software, system level software. application software and system software. So system software called as container runtime. So with this container runtime, what they were able to do is they were able to run different versions of the code or different versions of their workload on the same kernel. So the overhead of having multiple kernels was removed in this container option. So the only requirement was you need to have this runtime, container runtime. So if you have this container runtime, I can run different versions of my code on the same OS. So this looks like much better than the virtualization concept. So people started adapting this very well, and it became like the actual way to go going forward. So this is a small history. So from dedicated servers or bare metals to virtualizations to containers. So and in containers, one big advantage which you get is packaging all the dependencies together. Now, uh, you would have heard this popular dialogue from many. I also have mentioned this to many of the other people. It works in my system. I don't know why it does not work in dev environment. Why it does not work in production environment. This is a dialogue most of us would have done. Shared also told because it would have worked in our system. It's not that we are saying a lie, but it will work definitely in our system. But the same code, if it run if we try to deploy it in non-production environment or in production environment, it will not work. The reason is basically you can take a this thing, we can go through a small conversation here. So assume there's a developer. He joins the organization. There's a code which they ask him to write. So he writes something in Python. So he knows Python. He writes something in Python, a web application, web app. So for this, you may need certain modules. So certain libraries, dependencies, dependencies. I hope the spelling is correct. Dependencies, dependencies like Flask. Flask is a framework which can help you to write some web-based applications. Now he would have installed some specific version of Flask. Okay, done. Now he deploys this, shares the code, and the operation guy is going to deploy it. It's going to work fine. Beautiful. Job done. Now after 6 months, this developer moves into a new project, but he uses the same laptop. So same laptop, because why I'm saying the laptop is he had developed the first application, same laptop. 6 months later, he goes into a new project, maybe in the same organization. It has to be the same organization because it's the same laptop. So 6 months later, he deploys something. He wants to. He has a requirement. He gets a requirement that he needs to create one more application because he did with Python Flask last time. Everybody does the same thing, right? We know one technology, we would have used that. We will try to use the same thing in our next project also. What does he do now? He will not install Flask. He will not install Flask because it's already there in his laptop. So he will directly write code in Python, uh, and Flask is already there. It's a framework, that's it. So Flask is already there, and his app is already present. And what he will do is this time he's going to share the code with the team who's going to deploy it in a non-production environment to start with, and it's going to break there. The reason is this developer would not have packaged the dependencies, the complete dependencies, because first time when he did it, Flask was not there. For him itself, it was not working in his laptop. So he would have fixed it by installing these stuffs, and it would have started working. Now he's using the same laptop but a different code, so it's going to definitely work for him because the dependencies are already there. But when this code is deployed in a new environment, a brand new environment, it's going to throw us an error saying that the dependencies are not there, Flask is not there, it fails to deploy. So this can be easily fulfilled with containers. So that's one of the biggest benefits of container, and you can use this container in very simple terms as a containers which you see in your house, the kitchen. So you package it in such a way that it's going to be preserved. The content is going to be preserved as is. Maybe you can have a small cake which is put in a container which does not get spoiled. So it could be outside the house, it could be inside, outside, or it could be inside a refrigerator, but the stuff is going to be preserved as is. So because everything is packaged there. So that is one way of doing it. Basically, I would say put it as a container. So this is where the entire concept towards containers came into picture. Basically, you need to have just a container runtime. That's it. Now, before we go into an actual definition of what is container, let me show you some names. So dedicated hardware is nothing but your hardware from a provider. Hewlett Packard Enterprise, Dell EMC, IBM was providing in the beginning. Now I guess they have stopped it. So these are hardware providers. Virtual machines. So providers are VMware, Hyper-V, Zen, KVM, all those things. So Azure basically uses Hyper-V. AWS behind the scene uses Zen as the uh, they use Zen as a hypervisor basically, and GCP uses something called as KVM, kernel virtual machine. So these are stuffs. And when it comes to container runtime, many of us know Docker. We would have heard of Docker. But what is Docker? It is nothing but a container runtime. It's a container runtime. And there are other products in the market. Called as LXD, LXD Rocket, and Runc. The one which you see, there's a hamster in a cuboid kind of a stuff. This is called as Runc. So there are different container runtimes available, but one container runtime is very popular, which is Docker. The reason is in 2013, before 2013, this containerization concept of packaging the dependencies, running it in a different namespace, all those things was there in Linux uh, operating system for a long time. It was there for a long time. But if you were to leverage this container concept, right, you need to be a Linux Greek. You should go call some low level APIs, all those things. You need to be really a master in Linux. Only then you can leverage container concepts. So in 2013, Docker made this very easy. So you can containerize it, you can run containers easily by couple of commands. They made it so easy. So that is where Docker became very popular in 2013. The year is going to be important, folks, because we have something coming in 2014, 2015 in the next few slides. So it became very popular, and there are few products which tried to come up like Rocket, but the popularity of Docker was so high and it was so easy to use. So I would say 99% of the market share is with Docker. And that's the reason whenever people talk about containerization, they only think of Docker. So Docker is nothing but a software which helps you to create containers basically. But it's like synonyms now, like usually we used to in the past we used to say search it. Now we say it Google it. So Google and search has become like synonyms. The same thing is whenever people talk about containerization, they think only of Docker. Sometimes people also go and say Dockerize it. So Dockerize it and containerize it is going to be same. um, the whole reason is they made it very easy for the entire community to use containerization behind the scene. And just for your information, at some point of time, if you feel you want to create your own container runtime, if you have that kind of thought, you have an option. The option is to use something called as this one, the hamster, which is called as Runc or Run SC. So if you just search for that, Run C OSI OCI, sorry. So there's a open container initiative. So here you will see some specifications to create a container runtime. So the mother of all the containers, if you ask container runtime, if you ask me, it is this one, run C. So let me just show how do I spell this. So you can just search for run C or run SC, both are same. So there's a specifications, the Open Container Initiative. So it has been written as per this. And if you just little go deeper and look into Docker also, they have extended run C. So basically, any container runtimes which comes, they leverage this. This is like how C, every software behind the scene would have been definitely most of the time would be written in C. Like how it C is the mother of all languages. Run C is your mother of all container runtime. But throughout our class, we'll be focusing only on Docker. We'll not be focusing on Rocket or LXD. LXD is something from Linux itself. So every Linux has it, kernels has it, but Docker made it very, very popular. So now the names may be at least resonating very well. So containers, if you went to containerize it, the runtime which we are going to use, container runtime which we are going to use is Docker. So if I just go back to the slide, so this is hardware from Hewlett Packard Enterprise. Then I install a hypervisor. It could be KVM or Zen or Hyper-V. Then I have a Windows OS plus I may have Docker runtime there. Then I have my dependencies. Or the kernel could be any Linux distribution like Ubuntu, and the Docker runtime or the container runtime is Docker. So more than having a name, sorry, the labels, these brands could be really helpful for you to recollect what is these things basically. So now let's look into an actual definition from Docker, because it's very popular. That is the one which made it. So if you just go and search in Docker website, what is a container, you get a very simple, straightforward explanation. It is a standard unit of software that packages up the code and all its dependencies so that the application can run quickly and reliably over any environment. It could be in your laptop, it could be in my laptop, it could be in Google Cloud Shell, it could be in AWS, or it could be in a virtual machine in GCP, or it could be in Alibaba Cloud. It can run anywhere. So that agnostic thing has been achieved with the help of container, because the only thing which you need to run this container image, so the one which you create out of this is a container image. So you need to have a container runtime. That's it. So you have a bare metal, so you have hypervisor installed. So this part cloud provider is going to do that, so we don't need to worry about it. What we will focus is we want a host operating system. So in this diagram it is CentOS, one of the Linux distribution. So on top of that I'm going to install a container runtime. Most of the time it's going to be Docker. Then I can have different apps running on it. So different apps running on it where everything is packaged. Everything is packaged, meaning right from what OS till what version of the runtime you need. If you want Java 1.8 version or Python 3.7 version or PHP 7.2 version, you mention it to the complete details. So that way you will never have that dialogue repeated, needs to be repeated. It works in my system. That can be completely removed with this option. So in the example I have shown, you can have a lightweight Debian 9, which is going to have on top of that, you are going to have Java 8, some Tomcat application server running, and you can run some Java app. Maybe you want to run some PHP related stuffs, you can have this app. Something on machine learning, so you want to go with Ubuntu, Python 3.7 and some TensorFlow frameworks. So I package it in such a way that I can just run it on any of the system. And one small catch here, it's like whenever you say it can run in any environment, there's a small asterisk on top of it. Conditions apply. What does that conditions apply? If you containerize something in Linux, it gets, you can run it in any Linux distribution basically. If you containerize, and this containerization concept was there in Linux for a long time, as I mentioned, but in Windows this concept was not there. So, but Windows realized that this is going to be the future. So, in starting from 2016 server, 2019 server, they started adding this support for containerization. And in your desktop editions, 2000, Windows 10 supports containers. If you have an older version, you may not be able to run it. So, when you containerize it, one important thing is, at a high level you can say it can, when you containerize it, it's going to work everywhere. But a small underlying stuff which you need to mention it, if you have created the container to work on Linux, it's going to work only in Linux. If you have tried to containerize it on Windows, it's going to work only on Windows system. So that's a small thing which you need to keep it in the back of the mind. But most of the images which you see are always done for Linux environments. Basically, if you want specifically for Windows, you also have an option these days, which Windows 2016 and 2019 servers support it. Okay, so that's your containers, folks. Let me just stop here for any questions if you have, and we'll do a demonstration. Well, we'll do a demonstration slowly. uh, Hope at least now some concept are you are able to connect. You would have heard something, you are trying to connect it. Any questions, folks? Okay, now why do we go? Okay, can I say container and Docker is same? Container and containerization. Okay, containers and okay, I would say container runtime. Docker is one of the container runtime. That's going to be the better way to say it. So containerization is a concept, or container is a concept which you're going to do, and this is going to be achieved with the help of a runtime called as Docker. That's going to be the better way of saying it, Kumar. So it's one of the softwares. So I can also use Rocket, LXD, runc to containerize it. So I cannot easily say container is equal to Docker, but to containerize it, I need a container runtime. One of the runtime is Docker. So basically, hope that makes sense, Kumar. Now, we have already seen why this containers came, but let's try to recollect it by putting a slide here so that we get a clear picture why the entire industry is behind this containerization. So the first and the foremost thing is it's going to act as a lightweight virtualization. Virtualization is always going to be a problem because the OS footprint is going to be there, but this is lightweight. So this is lightweight. So the image itself, the OS which you're going to use is always going to be lightweight. So by that, what it's going to give you is you will get vCPU memory, you'll get an IP address, you'll get some storage. So it's going to look like as if like it's like a virtual machine, but it's not a virtual machine. So that's the first benefit which you get. The second benefit is standard packaging. So you package it, there's a specific way you have to package it, and once you do it, it's going to work across multiple environments on non-production and production environments. And this was the most important thing. The third point is the most important thing: portability across multiple Linux OS distribution. I have made it very clear. So if you have created something in Linux, it's going to work only in Linux. And most of the time, people prefer to use Linux only. Slightly, some people have started, and Google also started providing Windows-based support for containerization recently. So because of this portability, right, it can work across any cloud. Forget about cloud, even in on-prem it can work. The only prerequisite for me to run a container uh, image is I need a container runtime. That's it. Simple. If I were to open a text file, I need to have an editor, a notepad, notepad plus plus. It is the same thing. So file dot text is your container image. To open that, you need a software. That software is your Docker, which is nothing but a container runtime. So, and this is the most important thing, folks: parity across non-production and production environment. So I can just give you a small example here about this parity, how this works. So let's take a web application for instance. So, and let's make it very, very simple web application. So it has an app, Python app, and a DB, a database, MySQL database. So that's it, nothing else, very simple. One front end and a back end, that's it. So it's the developers have built this. Now they have containerized the app. It's containerized, it's packaged in such a way that it's going to work everywhere. The database, normal, simple. So two different virtual machines. So it's a normal MySQL database. Now you come to dev. So this is currently they have containerized it and made it available. So in dev environment, they come, they deploy this app, containerized app. So for this to run, you need to have, before that you should have Docker running. So Docker should be running. So assuming Docker is installed, it's going to work. So now you have MySQL DB, sorry, works fine. No more complaints. It works only in my system. Success, first success. So now from dev environment, it moves to the next environment, which is something like a staging environment. Staging also, you did the same thing. Awesome, working fine. So two success. The last one, production. So now you go to production. Production, here it fails. As usual, it fails. Now what you have done is the same image, the same container image which was built was used in dev, meaning this Python app is the same which is in dev. It is the same application in staging. Even in production, it is the same. It worked in dev, it worked in staging, but it did not work in production. Now, if you see such kind of a stuff, you can very confidently say the problem is not with my application or with my containerized image. The problem is with your database. I can easily pinpoint and say this is the troublemaker. So issue is here because it's the same image. So same image, you're promoting it from one environment to another environment. So this way it's going to help you easily troubleshoot if things goes wrong. And this I have used this very heavily, folks. Like uh, there is a database team and they lag, they are little slow. That's what I have seen, at least in my experience. I may be wrong. In couple of organizations where I have seen, the developers, the application developers are little faster. The only reason is there are multiple developers but only one database person. So maybe that could be the reason. So many organizations have seen this. So the developers do the changes faster and do it, and they would have asked for a change in the dev environment, the DBA would have done it. And now when they move to staging, it fails. The reason is there could be some database changes, the schema changes, which the DBA would not have done in staging environment. So the same code will not work in staging environment because the necessary database changes are not reflecting. So this is going to usually happen, and this kind of stuff has happened to me many times. And when I started using Kubernetes, I was able to, or containers, I was very easily able to point out the issues with database. So this point is very, very important. Parity. It's the same image. If something fails in a higher environment, it may not be because of this one, maybe some external factors. Maybe you have not sent the right DB credentials. Maybe the database changes are not there. Maybe the API, some third-party API, you have not enabled it. That's going to help you out to a great extent. And the last one is one of my favorite option, better version management. Meaning today you have one version running as an application. Tomorrow you want to deploy a newer version. You go and deploy it. Things will fail. That's the reality of a software. It will fail. If it fails, I can revert back to version 1 quickly. No problem. So rolling back to a stable version is always going to be easier if I do containerization, because everything, this containers are immutable. One version is one version. That's it. You cannot change that. So now you have a new version. If it's working fine, go ahead with it. If it's not working, just revert back to the older version. We'll see all these things during a demonstration. Okay, so that's where containerization really rocks. And this containerization gave one important thing: agnostic. You can build something which is environment agnostic. It could be in your laptop, my laptop, anywhere. So that agnosticness which gave was because of this containerization only. And this is where, whenever you are working with any customer, and if the customer says we want a cloud agnostic solution, the product which should strike you, or the service which you are going to use, is basically going to be Kubernetes, any cloud per se. So if you're in Azure, you use Azure Kubernetes service. Basically, whenever you want this agnosticness, because if I am running containers in Azure, I can run the same containers in GCP also. It's going to work for me. So that's something which was, I would say, the biggest benefit of containerization. Now, enough of lecture. I guess this was the first time, I guess, for uh, 1 hour, more than that, we were doing a lecture. Now let's get our hands dirty, where we will try to understand this entire concept of how to create a container, how to build it, how to run it, and how to test it. All those things we are going to do, and we are going to focus only on Docker. Okay, we are not going to use LXD, or we are not going to use Rocket or Runc. The focus is always on Docker. So Docker runtime should be installed on it, on the system where you are going to run the stuffs. So luckily we are going to do most of the demos on our Cloud Shell, and Cloud Shell automatically comes, or it's pre-packaged. Docker runtime is pre-packaged, so we don't need to worry about installing anything. And as I mentioned, always avoid doing those kind of stuffs. Installing, let me spend 1 hour installing something, that's waste of time. Since we are in cloud, you should be focusing on doing something much better. Installing is something which we used to do it on our laptops, so never ever do that. So try to see something where there are options where these are packaged. So one thing is our Cloud Shell. So most of our demos in Kubernetes is always on Cloud Shell, and we will not use Cloud SDK. The reason is, if you were to Dockerize all those things, you need to have on your Windows machine or on your Mac or Linux machine the Docker runtime installed. So it may not be, it may be sometimes more CPU intensive Dockers. So better to do it in your Cloud Shell. Okay. So now before we go to this demonstration, a small activity where I want you to also check, because everything is going to be on Cloud Shell, I mentioned. And I also mentioned Docker is going to be really little memory intensive, compute intensive. So it's going to take a good amount of resource from your this thing. So anybody ever tried to know what is the machine type of a Cloud Shell, folks? Just launch your Cloud Shell, and quickly see what is the machine type. Can anybody tell me what is a machine type? We know what is a machine type. Cloud Shell is also nothing but a virtual machine, which is provisioned in one of the data centers, basically. No? Let me know what's the machine type, folks. No? Don't give a guess. Go and work it out and let me know. You launch it and let me know. The answers which you people are giving were the older answers. Now it is changed. I want you have Cloud Shell in front of you. You can go run it and let me know. So let me know, folks. It was previously something, now it is not. Small activity, folks. Just launch your Cloud Shell and see what's the machine type. It could be an interesting one to do it also. And for folks who are in Asia, all our Cloud Shells are in the same project. You can use whatever the command. Try it and let me know. Your choice. But this is a virtual machine. To be very frank, right? Cloud Shell is not attached to our project. It is attached to this email account. It is attached to this email account. It's attached per email ID. It is attached. And if you visualize this, this is nothing but a GCE instance in a GCP project, which is not your project. Somewhere there's a GCP project which is provisioned, and everything is going to come from there. And people who are in Asia, all our cloud shells are mostly provisioned in two regions. I can very easily say one in Singapore or the other one is going to be in Taiwan, basically. So any info, folks, on what's the machine type? You could have used some simple commands, folks. Yes, Vijay Kumar, that was a correct one. So that was a correct one. So it is basically E2 series is what they are seeing. So how do I get that? The different ways of getting it. Simple. I would have used LSCPU. It would have given me the details. How much vCPU is it is running? So it shows 2. Then what's the memory? Different ways of doing it. LS, sorry, something like cat, proc, meminfo. Something around 8 GB if I'm not wrong. 8 GB, or if I use free minus M, yeah, 8 GB. 2 vCPU, 8 GB is something is what I get basically. Now this is a very straightforward Linux style. But since I told this is a virtual machine in a GCP project, how can I get those details is connect back to our instance group demo. Remember, in our instance group demo, we leverage something called as metadata server. That metadata server can help us to programmatically query the VM. So you can use metadata server and query it. There's a small script. Let me put it in the chat for you people. You can see it and let me know what is the stuff for you. So the machine type, for the machine type, you can try something like this. Just run it in your Cloud Shell, folks, and you should be able to see a response. Sorry, you need to put this thing. Sorry, my bad. Just put this single double quotes towards the end. So if I do this, it's going to show me basically something like this. This is my machine type. As Vijay mentioned, it is your E2 series. E2-standard 2 is my machine type basically. So if you want little better what's the stuff at your side, it could be E2 standard for sometimes, for some people E2 standard 4, for some people it could be E2 standard 2. So basically, but it should be usually E2 series. In the beginning, when Google started providing Cloud Shell, it was G1 small. G1 small. Now they have upgraded it and they are providing it E2 standard 2 or 4. Deepak Bhandari. The last number is important. That's going to give you basically what's your vCPU. It's 4. Oh, it's 4. That's good. So if it's 4 means what you get is basically you should have more this thing. So it should be 16 if I'm not wrong. So if I go to E2 standard, so what I have is this one, folks. What Deepak is having is E2 standard 4. So some people may have E2 standard 4, some people may have E2 standard 2. That's okay. So 8 vCPU, sorry, 8 GB is good enough for us to do all this Docker stuffs basically. Previously, right, Cloud Shell had a mode, something called as boost mode. There was a boost mode which you can boost it and do it. Now they have removed it because they are giving a decent stuff. Now, out of curiosity, if you want to run this command, let me just put this command in the chat. So you can just run this as is, and see a response in your Cloud Shell. And for people who are in Asia, my output and your output would reflect the same. So first thing, my virtual machine is provisioned in Singapore B zone. People who are in Asia, your project ID is going to be the same thing. Folks, you're able to hear me? I hear from Deepak. I'm not able, he's not able to hear me. Okay, thank you. So maybe Deepak, something at your side, please check. Deepak, the other Deepak, there are two Deepak. Deepak Bandari is able to hear it. Okay. So check it at your side, Deepak. What's the issue? So what's the output which you get, folks, for this command? Do you get something like this? The project not able to run the command. So why? Okay, sorry. You can just do something like this. 1 minute. You can just do this, folks. Remove that. Okay, it's not showing. Okay, it is showing. Yeah, you should be able to run it. Just try this. After this line, try this. Maybe if you put it in a script, it's going to work. Otherwise, you can just type this. Let me just type this. Just to have some engagement, folks. That's it. So that you also try something. So this should work directly if you directly run it. Or you put it in a .sh file and execute it. That's another way. So basically, this is the project ID, folks. This is a project ID where my Cloud Shell is provisioned and my machine type is E2 standard 2, basically. And my external IP address is this one. Do you get? For people who are in US, it's going to be again few stuffs, few options. Uh, so if I see Vivek Mishra's this thing, it is the same thing. So people in Asia, it's going to be almost the same, this thing, basically. The project is going to be same. So my VM, your VM is all in the same project, folks, at least in Asia. So it's either going to be in Taiwan or Singapore. The reason is simple. Okay, I got response from Mangesh also. So if you just go and search for Google data centers, if you search for Google data centers, you will see these are the data centers where the end user products get served, the YouTube, Gmail, all those things. The location wise, if you look in Asia, it is only in two locations. It's in Singapore and in Taiwan. So it's in Singapore and Taiwan. So if I just, so how I can know it is Singapore is basically we know this region, right? Asia Southeast one. That's it. So for people in US also it is the same. Strange. So okay, people who are in US, give a try, folks. Uh, it looks, it cannot be same. For people in US, it should be one of these countries. Uh, if it's Asia only, it's going to be Taiwan or Singapore. That's what I have observed. That's what I have observed. But the key part here, I wanted to leverage, okay, if it's little, okay, US Central, okay. US Central, okay, it is same project. If I see Deepak Bhandari is in US West, okay, so it's the same project, okay, it is the same project, provisioned it in different zones. So it's going to be US Central one for few people, US West one, US West one. What is US West one? US West one is Oregon. So it's provision from Oregon for some people. So basically one project, everybody's, if you see the output, everybody's output is so everybody's GCP project is, so all our Cloud Shell are provisioned in the same project. Looks like a little of a hack which we have got, right? We know where our Cloud Shell is provisioned. We know the project number itself, folks. We know the project number. So think of how you can get into somebody's Cloud Shell if you wanted to give a try. So just a small this thing. So, but you see the metadata server comes very handy. So we are programmatically querying and getting our Cloud Shells details itself, basically. And for some people it is E2, and some people it is E2 standard 4. For some people it is E2 standard 2. The whole reason for doing this activity is just to get you the machine type configuration, or the configuration of your uh, Cloud Shell, because Cloud Shell should be powerful enough, only then you can run these stuffs. Can you if you see it here, Kumar, if you just see, it's going to show E2 standard 2, E2 standard 4, E2 standard 4. There's no E4. It is only E2 series. E2 series, second generation E2 series. It's going to be standard hyphen 2. 2 indicates 2 vCPUs. 4 indicates 4 vCPUs. Hope it's clear, Kumar. Basically, for some people, it's going to be this one, E2 standard 4. All right. So that's something which I wanted to show. Okay. EOS is E2 medium. Okay. Some people are getting medium. Okay. So yours is E2 medium then. So 2 vCPU 4. So 4 should be good enough, I would say. Previously, right, Google used to provide something like this one. G1 small. This was what Google used to provide in the beginning. 1 vCPU, 1.7 GB of RAM. So they had a option of boosting, where you can boost it to N1 standard. Now they have given you a boosted VM already, which is really powerful one, I would say. Who is going to give you 2 vCPU, 4 GB of RAM free? Google provides you that. So we are going to use that and leverage our Docker skills. Okay. So what we are going to do now is to create a Docker, you need to have one file called as Docker file. So if you keep the file name as Docker file, that's good. But if you have multiple Docker files, you may need to add some names. Docker file front end, Docker file database, you can have it. So basically the default name is always Docker file, D capital F small. You create a file where you mention the complete details, what and all you are going to have. Basically, you need to mention, I have to have a specific OS, I have to copy certain dependencies, all those things. So this is the first step, folks. Now, who is going to create a Docker file? It could be an operation person, or it could be a specialist who knows how to create it. And there are tools which Google is now providing, where called as packers, where it can create a Docker file for you automatically also. There are multiple options. We will not focus much on creating a Docker file. We will assume there is a Docker file. We'll assume there's a Docker file, and we'll see how we can use that and learn our containerization concepts, basically. So where do we get the syntax? So if you just go to docker.com, you get a complete syntax. So the cheat sheet which I had mentioned, you'll get a complete cheat information how to create a Docker file. The from, these are some clauses which you're going to use, basically. You mention those things and you can get the stuffs automatically. So there's a documentation. I guess I have uploaded Docker cheat sheet in my Google Drive. So look into it for the syntax, basically. And I will try to explain you some of the syntax as we proceed further. So is there a Google proprietary tool to create a Docker file? Google will, it's not a proprietary tool, it's an open source tool if I'm not wrong. Packer or Builders or something is there. So you can use, there are multiple tools which you get to create this automatically if you want. There are tools available. Some cases you may need to write a Docker file by yourself by looking at the complete requirement. But that's not the focus of this class. Let's assume there's a thing, and I'll also show you at a very high level how can we create a Docker file. Okay, don't worry about creating a Docker file ourselves. There are a team who's going to do it, and I have seen in one of the consultation which I did, they had a dedicated team to create only Docker files. They don't do nothing anything else, they only create Docker files, and it's going to be around 30-50 lines basically. So what we are going to see is only like some 4 lines of Docker file basically. There's one product which Google launched, I don't like offering, which is again open source, called as Packer or Builder, something is there, I don't recollect the name. Maybe during the break I'll let you know, check it and let you know. But there are options for that. That's the first thing which you need to do. Once you do that, there's a process. This is where the credits goes to Docker. So you can just no, it's not Spinnaker, it's not Spinnaker. No, not Spinnaker. Don't worry about. So it's not. It's something with Packer. It's something called as Pack or Packer. I'll give you the name actually after the class or after the break. So once you have the Packer, Packer is what I feel. Yeah. So once you have your Docker file there, right? The credit goes to Docker for creating this so easy. You can create, you can build a Docker image with only these few lines of configuration or command. Docker build the name of the app. What is -t? It is a tagging. We'll talk about tagging later. So what is tagging? It's going to basically give you an option for tagging your image, version 1, version 2, version 3. If you don't tag it, it's going to become latest. That's it. Once you build it, you are going to have a container image. If you have a container image, you can run, test it, and see whether it's running. Docker run. That's it. So once it is running fine, you can then think of later sharing it with the other team, all those things. So there are options where you can store it in a repository called as Docker Hub. And I'll tell you why I have highlighted this in red color. And there are a few other commands which we are going to use in this process called as Docker PS, Docker images, all those things. So you will learn this as we go through the demo itself. Okay, so let's get into a demonstration. Okay, maybe we'll take a 10 minutes break. We'll, after we come back from the demonstration, sorry, break, we'll get into a demo where we will look into a Docker file. I'll explain the Docker file content, and we will try to create a Docker image. Okay, and this is not Kubernetes class, folks. This is, we are going back and understanding what is container, what is a container image, how do we create a container image using a container runtime called as Docker. So first, let's understand this, then we'll go to Kubernetes part. Okay, so take a 10 minutes break, and once you come back, we'll jump into the demonstration. So we will use our Cloud Shell to what are these things, and all the code is already uploaded in your Google, in the drive which I have already shared with you. You should be able to do the same demo after the class if you want. So let me stop the recording.
This conference will now be recorded.
Yes, it's recording. So what we'll do now is uh, we'll do this piece where we'll try to understand how the entire process works when it comes to Dockerization. Okay, so let me launch my Cloud Shell. So for a minute, right? And now this is one reason why I usually use, you see, if I do this, half of my real estate, not half, 75% of my real estate is filled with my path. So if I want to use PS, if I use this, the prompt comes to the beginning. So I get a complete real estate to type a big command. Now for next few minutes, right, I'm going to be a developer. And don't worry about the code, folks. If you're not coming from that background, don't even worry. I'm just going to show you what's going to happen with this code. So I have only two files. One file name called as server.js. What is this? Let me just show you. It's a simple 7 lines of code. Simple. 7 lines of code written in JavaScript, which is going to get executed using a runtime called as Node.js. Okay, that's one thing. What it's going to do basically, it's going to just, when I run it, it's going to just send me a message, welcome to containerization, where it is going to listen on port 8080. My application, 7 lines of code written in JavaScript, it's going to just run. When I run it, it's going to show welcome to containerization. That's it. Nothing else it's going to do. Very simple hello world kind of an application. That's it. Instead of hello world, I have just made it as welcome to containerization, and it listens on port 8080. This is important. It's not on 80 port like our Apache web server. It is on 8080. Okay. So let me first see whether this runs in my Cloud Shell. Cloud Shell is going to be my local environment for now. So since it is a Node.js application, basically JavaScript, the way I execute it is using Node like this. This is the way. Okay. And if it's Python, you're going to use Python, the name of the file. That's how you also execute this one. Why Node.js is going to be very lightweight? That's the only reason, nothing else. So let me run this. It does not give me any output. So it does not mean my application is not working. It is working, but it does not have any output to just show it on the terminal. Basically, it is listening on port 8080. Now I have to open port 8080 and see it. How do I do it? In Cloud Shell, because it's basically a terminal mode, right? So one option which I can do is put one more tab, and give a try with curl command, curl http localhost 8080. It's going to show welcome to containerization. So it indicates my application is running. But if I want to see it in a web, in a browser, how do I do it? Google provides you an option called as web preview, which you see on your next to your gear icon. You see something called as web preview. So if I just click on this, it's going to ask me on which port you want to do a preview. And there are some limited ports only. You cannot have a port of your choice. Prefer to use something which is more than 1024, because below 1024 these are all reserved ports. So I would prefer to use anything above that. If you ask me, I will use only anything above 8000, basically high ports basically. So since my application is running on port 80 only, right, I have an option directly here. So just click on preview on port 80. When I do this, if everything is running fine, it's going to just show me a simple message, welcome to containerization. That's it. Straightforward. Now I have an ambition. What is that ambition or a desire? To just let me just do Control C. Now go back. My wish is, as a developer, I want this. I'm fed up with this. Me giving excuses always. It works in my system and does not work in your system. I don't want to do that. I, as a developer, I feel I have to upgrade myself. I have to come out of that excuse stuff. And I wanted to run this very simple 7 lines of code everywhere. Everywhere in the sense, even in your Cloud Shell, it should work. It should work in our virtual machine. It should work in AWS or Azure. Anywhere it should work. That's my uh, wish list or my aim. Let's see how we can achieve that. Okay, so hope the requirement is clear, folks. 7 lines of code working beautifully in my local machine, which is Cloud Shell. But my aim is to make this run in different environments, meaning all of yours 12 members are there today, so all 12 members Cloud Shell, it should work. How? We will see. It should also work in a virtual machine, which we have good amount of exposure by this time. And maybe tomorrow we will try to run this in a Kubernetes cluster also. So that's our wish list. So what I will do to do that kind of a stuff, the one which comes to your rescue is Docker or Dockerization, to be very specific. You need to containerize it. Containerize and Dockerize are same, synonyms. So if I use Dockerization and containerization, don't get confused. Both are same. So basically you are saying it should run in multiple environments. The moment you say something like this, containerization is a good one, which is going to be a fit. So to containerize an application, the key prerequisite is, as per our slide, you need to have a Docker file. And the Docker file, I've already created it because that's not the main focus of this thing. So the file is already created it. I've created it. Let me show the content. So Docker file. It's only 4 lines of code, folks, or configuration. So what does that indicate? What are the stuffs? First of all, it's saying what do you need from what is the base image you are going to use, basically Node. Why? Because mine is a Node.js application, and I wanted to expose port 8080 from my container. What I should do, is there any code which I need to copy to the container? Yes, I have one file which is server.js. Copy it to a current directory in the container. How can we go inside the container? We'll show you. And the last command is, I need to execute this command, node server.js. Is this 4 lines clear, folks? Is this 4 lines clear? This is the simplest Docker file you can have with an hello world, all those kind of stuff. Simple, right? What is the, because we mentioned you need to mention all the dependencies, all those things perfectly. So that's the reason we are trying to use this. That's it. Now, that's the existing Docker file. Now, before I do anything extra, right, let me verify in my local system, which is my Cloud Shell, what is the exact version of Node.js running, so that I will not have any issue. So let me just see the version which is running in my system or in my Cloud Shell is version 12.14.1. This is the version which is running. So if you want, you can mention the specific version there also. Let's not take any risk. Let's mention this in our Docker file. So how do I mention this very easily? Because if you just go, and these are all coming from Docker Hub. So Node.js team, they have created a container image of Node.js and they have uploaded this into Docker Hub. So if you just go to Docker Hub and search for Node.js, you should get an image like this. So if I just go Docker Hub, this is where all the images reside, basically. If I search for Node, you will get good amount of stuffs, and I will always prefer to rely on official images, folks. Official images. So if I just go to this, basically, this is the official image, and the various versions which they support. Everything is going to be in this format only, version. So that's the reason we are also putting the same thing, 12.14.1.14.1. That's it. So that we'll not have even a version difference. Everything is captured. So done. We have a Docker file ready. Now, how do I do execute it? So if I just go to my slides back, I'm going to refer back to my slides back. So there are two options which I can do. The simplest option is Docker build -t is the tag which I wanted to create, and a name to your image which you want to give. My app with a version or without a version, and you need to mention a dot in the current working directory. So what it's going to do, basically the dot indicates is basically what is the content which you need to copy and where is your Docker file. So in my case, inside this container, what is that folder? In this folder, container-j node.js, I have my Docker file also. I have my server.js file also. So if you have everything here, you can just do Docker build -t my app version 1.0, and you need to include a dot. So where it's going to get these current files needs to be copied, basically the server.js, and there's a Docker file with the name Docker file itself. So this is what it's going to do. This is a simplistic way of doing it. Let's try to build it. So before we build it, right, this option you can try it yourself by doing the simple stuff. What I will do is I'll try to show you a slightly complex stuff. I'll come out of this folder. So I'm currently outside of this folder. Now what I will do is I will do something like the other command which I mentioned. Docker build -t, the name of your app, what you want, -f, and where is your folder, what is your file, all those details you can mention it. This makes more sense when you're going slightly in an advanced level. So Docker build -t, what is your name of the app? My app version 1.0 -f indicates where is your Docker file. My Docker file is here. This is where my Docker file is there. And what are the content which needs to be packaged? So all those things are in this folder. Now this is what I can mention. Now before I hit enter, I wanted to put time in front of it, just to know how long this is going to take. Now when I hit enter, what's going to happen is my Cloud Shell is going to connect to internet, go to Docker Hub, going to pull a specific version 12.14.1. If it exists, it should exist is my understanding. 12.14 should be there. It should be there. After that, it pulls. It's going to create the next step. These are called as stages or layers. So the next one is to expose port 8080, then copy that server.js file and make sure the command is node server.js. That's what it's going to do. Let's see how long it's going to take for all the steps. So that's the reason I'm putting time in front of it. Hit enter, and this entire process is very intensive, processor and memory intensive. So here our server Cloud Shell is going to help us because it's slightly powerful system. It's going to be a good one. So you see our version is there. Our version is there. So it has pulled it. It's pulling from Docker Hub currently now. And it's a public image. No restriction. That's the reason I'm able to pull it. It's taking time. And we are in the step 1. We have 4 lines, so 4 steps. Now the second step, we have exposed it. Third step, copied server.js to the container. The fourth step, it should be executable like this. The entire time took around 38 seconds. Please make a note of this somewhere, or I'll just put it in the chat. The entire stuff took 38 seconds. You can ask, it's only seconds, right, Mahesh? Is this again mattering? Yes, it will matter, and we'll slightly go and enhance this. Even this is going to be something which we can reduce it further. So done, and you see it is successfully tagged. And this is the image ID. Now how do I see my images? Simple. Docker, so let me just Docker images. If I do it, it's going to show me the stuff there. Now why 2 images? One is a base image where you mentioned I want node 12.14.1 exactly, and this image was built 12 months ago, almost an year back. And there was another image which you just created 49 seconds ago. That's it. Simple. So we have our container image ready, folks. It's just now a matter of running it. Very, very easy. Now, before doing all those things, right, we were so easily able to run Docker build in our Cloud Shell. The reason was Docker was already installed, as I mentioned. So the latest version, or the so-called latest version, is already there. You don't need to install anything. People who have tried to install Docker on a Linux machine will know. So there are some good amount of steps which you have to do, but we don't need to worry about that because it comes built in with our Cloud Shell, which is really an awesome part. So because Docker was there, Docker runtime was there, with my Docker file, I was able to create an image, a Docker image, and it's ready. The only step which I need to do now is do the second step, run it and check whether it's going to run, basically as expected, as a containerized app. It's a containerized app. Let's see whether it's going to work. Now before I run it, right, it has come up, it is showing all those things. Do you see any concerns so far, or any issues or any questions so far? Do you have any questions, concerns so far, folks, with what we have done? We had 7 lines of code, and it is using the Docker file. We have built it and we have got an image. Now there's one question from Anil B, where all this image gets stored. Can I store it in one of my folder, or can I explode, unpack my image to see what all it has? Possible, definitely possible. So there are two parts to your question. Where all this stuffs get stored is a very good question. If I type Docker info, I'll get the details of where my images are going to be stored. So here, if I do Docker info, it's going to store everything. This one, Docker root directory. It's going to be /var/lib/docker. So this is where all my images are going to be stored. If you want to see it, so because it's /var, right, I will become a root user. Then I'll go to /var lib docker, and if I go to basically overlay, these are my Docker images, Anil. So these are all in the binary format, and there are few commands, like you can also use tar command to untar it and see what is there inside it, basically to unpack it. Tar command will help you out to untar it and look it. But these are your images. So du minus h, around 958 MB or so. So this is the place. How do you know that? Just type Docker info. That's it. Let me exit as root user. You can also use, okay, Docker inspect. I never tried, Vijay. So Docker inspect is something which you can, okay, let me try Docker inspect. I never tried that command. Okay, on an image you have to do it. Okay, got it. You can do that also. So maybe I'll put this comment which Vijay has mentioned. Anything useful, if you feel, to the entire people, put it in the everyone, folks. Now I have my image ready. It's only one step where I have to go and start it, run it basically. Any other questions till now, folks? Any concerns do you see from the screen? I have one concern. I have one concern. And to just help you out, I'll try to show you one more thing. Du minus h server.js file. So something on this, does it give you any concerns here, folks? Looking at the screen, Kumar did not understand what is static there. Size. Size is something, yes, Anil, size is something which concerns me a lot. Now, what was my ambition, folks? Server.js should work everywhere. And what is the size of that file? 4 KB. Now, to fulfill your this thing, ambition, do you need to have close to a GB? Not acceptable, right? So something which needs to be tuned, fine tuned. So we'll just keep this concern at the back of our mind. We'll try to fix it in the next time, but just keep this in mind. The size should be in an acceptable range, not like this, 1,000 times higher, not at all acceptable, I would say, more than 1,000 if I'm not wrong. So this is one concern. I'll show you how we can address it in next few minutes. Okay. Now we have our image there. Now it's 6 minutes ago, which has been built. Let me just go and run it. How do I run it? Docker run the command which is mentioned there. You can use it. -D. -D indicates basically you run it in a background daemon mode. That's it. -P indicates the port on which you want to run. Listen on basically. So the first port is your host, your Cloud Shell. In Cloud Shell, what port you want to run, and the second port which indicates is the port of your container which is exposed. Okay, the first is what is the port you want to listen on, and what is a port the container has exposed, followed by your container image with the complete tag information. Let's go and try it. So -D in a daemon mode, -P the port. I'm purposely going to use 9000 port so that I can show you in a different port. 8080, my app name, my app, the version is, that's it. So the same command which was there. So I don't need to remember it. It's there in the slides. I just used it. That's it. I'm just learning. So later I'll try to make it without looking into the documentation. Let me run it. Done. It just shows it is running and it gives a very long alphanumeric character. Now, do I know whether it's really running or not? So in Linux, to know whether a process is running or not, what is the command which you use, folks? In Linux, usually, to know whether a process is running or not. PS. So simple. Since you're looking at a Docker process, simple put. Docker PS. That's it. So it's going to show whether that this thing is running or not. If you see the Docker container ID, it is the same thing which you see here, the first few letters. So it is running. So 30 seconds ago it was created. Up status, it is up. You look at here, folks. This is your port forwarding which is happening. Now Docker gives you a Docker container ID and also something called as name. Strange Nightingale. That is the name of my container ID, because some people may not be so comfortable remembering the ID. So Docker gives you a name, easy to remember. So my Docker is, my container is running. It's running and I can access it from my host machine, which is my Cloud Shell, via port 9000. How do I do it? Just click on this, change the port, because by default it's 8080. Change the port, type your port, and you cannot type anything random here. There are some restrictions. So 9000, I know it works, so that's the reason I gave it. So change and preview. Awesome, it's working. No change in the output, but what we have advanced is basically by running simply on a normal virtual machine, we have containerized it. The output remains the same, but this is now output coming from our container. A slight enhancement is what we have done so far. That's good. Now you want to try to run one more instance, you can just go use this, but please don't use the same port. Otherwise, because now 9000 is already running. So in my Cloud Shell, 9000 port is already blocked. So maybe 9010. You want to run it? Run it. So another process is what you are running. So I'm scaling it. I'm scaling it, folks, manually. So Docker process. You'll see two processes. So one 9010, other one is 9000. So want to try it? Try it. It's going to work. So change 9010. Log in. You should be able to see it. So kind of an auto scaling, which is what we are doing. So we are not come to that stage, but just wanted to show you can run it on multiple ports, but your container port should be the same. because that is what we have exposed it. It cannot be different. But on your host machine, which is your cloud shell, you can run on a different port of your choice, basically. All right. So now if I do Docker process, there are two processes running and they have their own ID and their names. All good. Now, this is for people who are little more curious. What is this container? What is where it is running? How can I see some details into it? That kind of curious people. I'm also one among you if you are that curious. So when I learned my concept, I learned it this way only. So I just wanted to share you that part. So this is a process at the end, right? It's a process running at the end. So now how can I see this really? Is was very curious. So to know that, right, let me just show you this command. First of all, I'm in my host operating system. Node version is this, and my host operating system is Debian 10 Buster. That is the stuff. Okay. Now I'm just going to clear the screen, do Docker process. There is a command using which I can connect to my container easily. So there's a command called as Docker execute IT interactively login to a specific container. So you can use the container ID. If you don't like the container ID, you can use the container name. So I like the strange nightingale. I'll just put this, and because it's a Linux one, the mode in which you want to enter into it, bash mode, sh mode, you mention it. So I'll go with sh mode. Now you see a prompt change, folks, from dollar, which was where I was in my host operating system. Now I'm inside my container, and you see the prompt. Hash indicates I have logged in as a root user, basically in my container. If I just put ls, this is my container environment. So where is my server.js? So if I put print working directory slash, so because you remember there was a line which we had mentioned in our Docker file. What was that? Cat, this thing. So we mentioned copy our server.js to dot. So dot was slash. So it just copied it there. That's it. Our Docker file is not copied. Our server.js file is copied. Now, if I just type process inside that, process minus ef, it shows there is one process running. And what is the Node.js version? Let's just check it. This is inside the container, folks. Version same, because we had mentioned it very clearly. What is the OS here? Debian 9. You see this? The Now, yeah, this thing is going to become very clear now. If I just go one couple of steps back, you see this? This is something like this. The host operating system in our case was Debian 10. We have a Docker runtime, which is our container runtime, which is our Docker. Now we have an app which is using Debian 9 with Node.js specific version. Now things are becoming clearer, folks. Is it becoming clear? So we are inside our container, which is using a different OS altogether. So how this OS came, basically, it's very simple. When Node.js people created Node version for 12.14.1, they had used Debian 9. Maybe 1 year back, Debian 9 was available. That's the reason they packaged it there. So when they wrote the Docker file, right? They would have used something like from Debian 9, something like this. This is how they would have packaged it. So that became our base image, and we are now using it. Any questions on this, folks? Till now, I'm in my container. If I do exit, I will come out of my container and my prompt changes to dollar. Now I can see my processes. Okay, let me explain it one more time. So for that, it's better I exit this and I go to a new tab. Let me explain it one more time. So I'm in my Cloud Shell, folks. Now look at this prompt. This is the prompt. I'm not going to use PS1, so let this prompt be there. Now if I do Docker process, there are two processes running. Now what I will do is, I wanted to see what is running inside this. So my host operating system uses this version, and my host operating system version itself is Debian 10. Till here, is it clear, folks? Till here it is clear. This is all about our host operating system. Now, what I will do is, I will see what is the OS which is used by Node.js 12.14.1. How do I know that? I can just do this docker execute interactively, log into any of these stuff. I can use my container ID also. If you can remember it, okay. If you cannot, use me your container name. Then I can log in using sh mode, bash mode. Last time I used sh mode. Let me go with bash mode now. If I do it, please look for this prompt here, folks. Currently the prompt is this one. Now when I enter in bash mode, look at this, folks. What is this? Root. I have logged in as root user inside my container. And what is this ID? Do you see this ID somewhere, folks? What is this ID all about? This is nothing but your container ID. The container ID. This is your container ID. So now if I put ls, I'm in my root directory slash, I see my server.js because I had mentioned copy server.js dot. If I had mentioned something like copy server.js slash root, then it could have gone into root folder, basically. That's one thing. And if I look into my OS details, out of curiosity, my container is using currently Debian 9, basically. Debian 9 and Node.js 12.14. So this way, I will never have, because my requirement was I have to have 12.14.1 exactly. I was very precise in my requirement and it worked. What OS? I was least worried about it because I was under the impression Node is going to take care of it. If I want Node, they would have packaged it on a specific OS. It's okay. For me, the OS is not important. What is the version of my runtime is important. So I just mentioned it. It worked for me and it is working. So is this clear, Anil? So you asked for a repeat. So hope it is now clear. Let me know if it's not clear. Yeah, awesome. So now let me exit. Now if you see, I'm in, it is hash. Now if I exit, I come back to my prompt, which is my Cloud Shell. So far, so good. Now, if I go back, we had a Docker file, we built it, and we took a tougher step of doing this option. I would suggest you to do this if you want to give a try. That's straightforward. We ran it, it worked fine. Step 4 will not do, we'll come to that later. We are still in the exploration phase. Now, time. We have explored it to a great extent. Now, time to fix that concern which most of us had. What was that concern? The size was very huge, really not acceptable. So we came back from virtualization to here. The only reason was because virtualization footprint was big, all those things. Now here, your image itself is around 1 GB. Does not make any sense, right? So how do we fix it? The reason why this is slightly higher is it was using Debian 9 version. So it was the main reason why it was little heavier. So that was the reason I specifically showed you that OS details and all. Now, how do I make it lightweight? So one of the best practices of containerization is your container image should be lightweight as much as possible. And one Linux distribution which you get, which is going to be very lightweight, is called as Alpine. So if you just search for Alpine This is the smallest, simplest, secure virtual machine which you get in Linux. So if I go to about page, it's going to be around 100, 150, some kind of a range. So if you see the size wise, this is important. The size matters. So somewhere they would have mentioned the size. So around 130 MB. That's it. Simplest one which you can get. Now, what we'll do is we will change our base image. We'll change our base image. What was our base image? We did not mention anything, and because of which it took basically, if I put vi docker, it was node. Base image was node, and that to 12.14.1. If we just mention like this, Node.js always builds it with Debian 9, basically. Now, what I wanted to do is, if I go to this node, Docker Hub, where the node is uploaded, a quick observation, it shows us usually node packages it in 3 different flavors: Alpine flavor, Buster, which is Debian. So they package it in 2 different OS. If you want lightweight, go with Alpine. If you want a little more more features, go with Buster, which is the latest Debian 10 version. So if I just put Alpine, I would say our size can come down, is my understanding. So looking at the pattern, I just need to mention Alpine somewhere. That's it. Let's give a try, folks. Let's give a try. So what I will do is, I'll just follow the pattern there. Hyphen Alpine. That's it. Let me just do with hyphen Alpine. That's it. Only one change. Now, what I will do is Docker process. Sorry, I'll just stop this process first because my VM is only E2 standard 2 vCPU, 8 GB of RAM. Running these things will definitely take time, so will consume more resource. I'm going to stop my process. For one, I'm going to use my container ID to stop it. Then for the other one, I'm going to use strange nightingale. This is my, I can use either one of them. Now, if I do Docker process, the first one would have been stopped. Nightingale is still there. Let me just use this one. Docker stop. Why I'm stopping? Because I don't have enough resource, folks. That's it. I tested it. Everything is working fine. By doing this, I also learned a new command, Docker stop. That's it. Now, if I put Docker process, nothing is going to be there. Now I am good to do my Docker build. So last time we did something like Docker build. If I just do this, we did something like this, right? This time we'll do a slightly different one. What we are going to do basically is, because we are already inside the current working directory, I'm going to do Docker build. First of all, let me get the image name. Sorry. So what I'll do this time is Docker build -t my app version 2.0. I'll just put dot. That's it. I'll put dot, and this time I'm going to make time in front of it just to know how long it is going to take. Because it's an Alpine image, the size itself is less. To pull that from the Docker Hub, it's going to be much faster. So size is also going to be lesser. Build process is also going to be lesser. So it's a win-win situation. Let's see how long it takes. When I say it takes shorter time, it takes longer time. So let's see whether that image exists. Okay, no magic. Everything is live there. So it took 38 seconds. This one is taking 17 seconds. You see it by yourself. So faster we built it. Now, the most important concern was the image size. Let's see whether we have fulfilled it. Awesome. That was a cool one is what I would say. So from 900 MB, we came to 85 MB with no compromise is what I would say. Is this acceptable, folks? 4 KB a file to containerize it, definitely there's going to be little overhead. 100 MB, I would say it's an acceptable one. Is an acceptable one. If you still want to reduce it, I guess definitely you have to look into some more optimizations of Docker. But with my limited knowledge, I would say from 900 MB coming to 85 is a good attempt, is what I would say. Now, there's one question. Can we have node image to use a host OS rather than Alpine? So you can use it. There's something called a scratch. I have not get enough documentation on that to do that, to leverage the host capability itself. So there are some option called a scratch. I'm working on it to get a working example, but I've never got it. But usually they use a lightweight OS like Alpine Anil. So that way you're going to have it. So for example, right, let me make it very, very simple here. So if I type this command, which node.js node, my node is currently in this location. Now, if I do this command du minus sh, copy this command, it's going to show my size. The node itself, the node executable itself is 44 MB. 44 MB. With my Alpine, all those things, it is coming to 85 MB. So there are possibilities is what people say, but I have spent good amount of time. I was not being successful doing this. There's an option called as scratch. If you search for this, you will get something, but they always give a hello world example. Hello world example, which is not of use for this kind of a requirement. So now we have reduced the size to a great extent. Why don't we do one more last time? Run this app and see what is going to be our basically our OS. Verify it. Let's verify it. Docker run minus D minus P 9090 port, 8080 is my container port. I want my app. Which version? You see that versioning comes very handy, folks. Versioning comes very, very handy. So it's running. Now, if I see Docker process, it is running. Now we are running our second app, which is 85 MB basically. So how do I log in into it? Docker execute minus IT. The name is Crankly. This is the name. You can use the ID also. And uh, this thing, what is that? Alpine does not provide you bash mode. If I do it, it's going to throw me this error because bash mode does not exist. So what you should do basically is you have to do it in sh mode only. So if you do in sh, it is coming to your this thing. Now put ls. This is your Alpine OS. How do you verify it? Simple. Just do cat etc OS. You see that? Alpine is your container OS and your host OS is this making sense, folks, till now? So how we had a wish, we tried to do something and it was slightly not acceptable. We tried to optimize it with a known image Alpine lightweight, and we also verified when we do it, it's going to be lightweight, and it came with really lightweight size, and we also verified the OS. So till here, is there any questions, folks? The concerns which we had, we have fixed it basically. Anything till here, folks? Any questions? Because this is slightly new topic for most of us, so that's the reason I'm pausing and asking explicitly, is there any questions? So If there's no response, I'll assume it is this, everything is good. Which part of the thing which you want to explain? Port forwarding. So port forwarding, you want to explain it. Okay. Port forwarding, Docker process. So if you see, let me just kill this process first of all. Or let me just run this. So what I'm currently doing is in our Docker, we mentioned our application listens on port 8080, and that is the reason we had exposed that port. So in our container, port 8080 is what is going to be listening. But in my host operating system, which is my cloud shell, port 8080 is not available. So what I do is I usually run it on a different port. When I use it on a different port, usually from my host operating system, the port forwarding gets happened. It goes to port 8080 when it reaches the container. How do I do this, make it happen? Is when I do my Docker run -d. So I mentioned, if I don't mention this, it's going to be basically 8080. If I mention it explicitly, then it's going to listen on that specific, like use that port and do the forwarding. It's running. Now if I do Docker process, I should see those port forwarding. All right. So that's the stuff. Now I don't have enough compute. I have to stop it. So first of all, the wish list is coming slowly into reality. I'm able to containerize it with a decent size. That is good. But what was the most important thing of Docker, folks? Run everywhere. So that is something it should happen, right? It should be able to run everywhere. So first, let me stop this and see how I can achieve it. How can I make it run everywhere, folks? Currently, it is in my local system. I cannot give my local system to you, right? I have to make it somewhere, put it in some repo. So I have to make it, put it in, maybe I should put it in Docker Hub. Then only I'll make it, it's going to come to you. Otherwise, how can I share my VM with you? So that is where this part comes into picture, where you can push that into a Docker Hub. But why it isn't put in red color is basically you need to buy a subscription. So if I just go, I have a slide there. So if you just go to Docker Hub pricing, what is Docker Hub? It's a hub for all your container images. This is the place. So if you have a source, where will you keep it? GitHub, Bitbucket, Subversion. If you have a container image, where will you host it? In container registries like Docker Hub. So you put it in Docker Hub and share it with others. So, and these are the pricing models which you have. Now, free for everybody. This is the clause which they mention. And there's something which I wanted to highlight, something in red. What does that mean? Unlimited public repositories. This is going to be good if you are learning something. But if you're in a corporate, you cannot have a public repository. The container which you have created, the image which you have created is basically proprietary. I cannot make it public, right? So if you are in a corporate, this free free tier or free package will not work. Then you have to go at least for team or large, where you get basically unlimited private repositories. This is what I need. Meaning, if I were to use Docker Hub, I have to buy a subscription. Now you may say, what is buying a subscription so concerning? Now just think as a customer for a minute. They wanted to go to Google, GCP. They expect the financial team, the financial team in the organization expects one single bill, one single invoice at the end of the month, one from Google Cloud Platform. That's it. Now, if you go with the subscription, and these days every subscription is per month or yearly base, they will get 2 invoice. So it's going to be an overhead, right? And also, if you are act as a cloud architect or as a pre-sales person and you are in front of the customer, if you say we can go with containers, all those things, towards the end you say please also buy a subscription from Docker. Does not sound so good, right? It's going to be more concern for the customers. So that's the reason we will never, at least in our class, we will never use Docker Hub, but rather we will use a product which Google provides called as Google Container Registry. You can use JFrog also if you want. I have not looked into the JFrog, but you can use it. That's one. It's going to be an artifact registry. So you can use that also. But since we are in GCP, if you use GCP products itself, it's going to be always one invoice. Just think from different angles, folks. As a customer, one invoice is always easy, right? So, and also, sometimes if you are writing any response to a tender uh, for a public sector organization, and if they say everything should be one-stop shop, this is not going to work. So you cannot buy subscription from Google, subscription from Docker, subscription from GitHub, all those things. One product, Google Cloud Platform. Every stuffs you will have it. Now it may have some limitations, all those things. That's okay. But at least from the compliance perspective, you can have a container image stored in GCP with a product called as GCR, Google Container Registry. And big advantage of this one is whatever you keep it in GCP, it is always private repository. It's a private repository, and the price of the stuff is going to be very, very cheap. It is basically based on the size. It uses Google Cloud Storage behind the scene. So in Google Cloud Storage, it's going to be multi-regional. We have not talked about much about it, but the price is going to be $0.026 per GB per month. I would say, and this is enterprise grade. So here, when you want a large thing, you don't have a price information, you have to contact sales. So I would say better than Docker Hub, at least from the price perspective, GCR looks better. And that too, it's going to be GCP itself. The integration is all going to work very easily, basically. So meaning, if I put it in GCR, I can share it with you people. I can share it with anybody. If I put it in Docker Hub also, I can do it, but it's going to be public. I don't want to keep my image public there. So if I want to make it as private, I have to pay something. So the minimum is $5 per month. I don't want to do that. So instead of that, I'm going to use something called as container registry. So that's what we are going to see, how to explore container registry. Now, before we go to container registry, you may think, can I keep my stuffs in Cloud Shell itself? Maybe now I'll run it. Maybe after the lunch, I'll come and again start working on it. What will happen is in Cloud Shell, as most of us know, it is ephemeral. It is ephemeral. Cloud Shell is ephemeral. And all my stuffs in my Cloud Shell, all my images are stored here. Is this partition persistent, folks? /var/lib/docker. Is this going to be persistent or not? No, it's not. It cannot be. So the one which is persistent is always ls block /home. It is not /var. So meaning, if I just restart this, if I just restart in front of you only, Docker images, you see these images. Now if I go to sudo -s /var lib docker overlay, these entries which you see all would be lost if I just do a restart. Let me just show you the stuff. That gives you a very clear indication it's ephemeral, 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 basically. So the Docker image is going to be ephemeral if you just leave it in your Cloud Shell. So Cloud Shell is only for building. That's it. Once you have built it, you have to definitely push it to GCR or push it to Docker Hub. So that's very important. Let me just restart my Cloud Shell. By the time it comes up, let me just wait. So too many jumps will become very difficult. Yeah, after this I'll definitely have a break. I'll just I'll just show you this part and then we'll take a 5 minutes break. Hope 5 minutes is okay. Or if you want 10, I'll give you. I'll make it 10 itself, folks. Today was slightly a difficult topic, so it's worth taking a 10 minutes break. So just wait for this VM to Cloud Shell to come up. We'll just do Docker images and see nothing is going to be there. Back to square one. Nothing will be there. Came up. Docker images. Bye. Nothing is there. All your stuffs. 1 hour what you built, everything is lost, folks. Everything is lost. Now if you just go to cd/var/lib docker overlay, nothing is going to be there. There's one character. I don't know what is this. U minus h some 4 kb. I don't know what is this. It's something like empty basically. So nothing is there. All your stuffs are lost basically. So it's very important. You always push it to your GCR, cloud source Google Container Registry. So we'll see more about Google Container Registry, all those things, because it's a new service. We have to check whether it has to be enabled or not, all those things. So we'll do all those things once we come back from a break. So let me stop here, stop the recording.
This conference will now be recorded.
Now, before the break, we understood Docker Hub is going to be a little expensive, at least for us for doing this session. Uh, we don't want to pay anything, so we can use anyway. We have activated our free trial account. We can leverage container registry itself is what we are going to do. And also, if the customer is already having Docker Hub, JFrog kind of artifact registry already, they can continue using it. There's no harm. But if it's a new customer and they don't have anything which is ventured yet, maybe Google Cloud itself is enough. It's going to provide you container registry. And if some people, and we will see by ourselves, container registry is not that robust. We will see a couple of stuffs where I'll show you it's not that robust, can be fulfilled with a new product called as artifact registry, so which is generally available from November 2020. So it's almost like 4 months old product, which is, I would call it as a next generation version of your container registry, GCR. So what are the things which it cannot do basically is fine granular access. If you were to give access to only to one specific group, that kind of a stuff, it's not possible. You cannot create repositories in a specific region. It's going to be usually multi-region in container registry. Language supports are not there. If it's Java, you will have support for Maven. If it's Node.js, you will have support for NPM. So that language specific support is not there in container registry, but artifact registry provides you that. And there are other few features which artifact registry provides very easily. Now, I would suggest if you are using any artifact registries like JFrog kind of a stuff, it's always good to compare JFrog with artifact registry. Comparing JFrog with container registry is not an apple to apple comparison. Just wanted to share this information. The reason is, who knows when this beta exam will become GA. I don't have any idea. So even if it's slightly a newer feature, I thought I will share you with that information. And this slides is not there. So by end of today, I'm going to upload it in your Google Drive. So you should be able to see that updated slides there. So this is a step so that by April, if you finish it by that time that beta professional cloud architect exam becomes GA, you may expect some questions on artifact registry. That was the reason. At least I wanted to put a word there, right in picture there. Is a fact and is for image, right? So okay, you are correct. So the container container registry, right? It is only for GCR, Google Container Registry is only for Docker. Artifact registry, you can also put a few other stuffs like uh, May, Paven, sorry, not yeah, Maven, and you can put something for your Node.js also. You can put other artifact stuffs, basically, like OS specific stuffs, all those things. So it's a superset, basically. So maybe I can show you the demo of contain artifact registry tomorrow. So first, we have not even seen the demo of container registry, so we'll not jump into that. First, we'll see this. So this is a superset. Artifact registry is a superset which can not only hold container images, it can also hold language-specific images like uh, Maven, NPN, APT, all those things. So because these are all new services, right? By default in GCP, not every service is going to be enabled. So you have to check whether the service is enabled or not. If the service is not enabled, if it's not enabled, you have to enable it basically. So before enabling anything, this is a practice which you should follow, folks. Right from today onwards, we have enabled few services in the past, like Compute Engine and all. So whenever you enable, before you enable any service, go to your IAM. Go to your IAM. Check, take a screenshot. What are the various roles available? Then go and enable your API and see what are the changes which happens. That way you will come to know what are the services which is going to be changed, what are the service accounts which is going to be created. You'll get a complete picture. This is a small activity which you can do. For example, here. So that's the reason I told IAM will never stop. It is always going to continue. So here we are going to turn on certain APIs. When we turn on those APIs, right, you will see before it, it's going to be only this one, Compute Engine default service account, one Google managed service account. Maybe you may have few stuffs with the owner roles, all those things. Once you enable it, you will have two specific roles related to container registry and to Kubernetes. We'll just do this part because we need to see whether container registry is enabled or not and Kubernetes is enabled or not. It may not be enabled in our account. We'll just verify this. Once we verify it, we will do a build process one more time, which is specific to GCP. The steps which you saw in the last 1 hour was something unique or something like it's generic to any cloud. But now what we are going to see is basically which is specific to GCP. So the specific to GCP is I'm going to use gcr.io container registry. That is going to be my repo when I push it. So I have to tag my image also in that fashion. So this is something specific to GCP. So let's just do this. For that, first of all, let me just go to my this thing. First, go to my IAM, folks, and see what's there. What are the roles which we have? This is a good activity, I would say. So that way you'll know the internals to a great extent. So we have only three entries. One is our default service account. The other one is a Google managed service account, which I told never ever touch or never ever do anything to it. The last one is the owner, which is me. That's it. Only three entries, but there are few other hidden entries which you don't see it by default because there is a field which they have enabled here. So previously, right, you were able to see everything, but now Google has made it as a good step because sometimes people out of curiosity come and delete this account. It's going to create a trouble. So what they have done is they have put a filter. If you want to see any Google managed keys, go and turn this, Google managed uh, service accounts. Google managed service accounts, you just turn this on, then only it's going to show. You see some few things are Google managed. These are Google managed one. So, but we don't see anything related to container registry and we don't see anything related to Kubernetes so far. And what I will do is I'll go to my another screen so that I can show you what happens when we do the next thing. So let me see whether my API is enabled or not. So to see whether my API is enabled or not, I can go to console and check it, but I wanted to show you in the command line. Gcloud services list. What are the services enabled in project 6 is what we are going to see. Why we are looking all into this? Because we are looking into a new product. So do I see container registry somewhere, BigQuery? I don't see anything, folks. I don't see anything here with respect to GCR or Kubernetes. So what I will do is go look into my GCR. Where is GCR available? Under your tools, you will have container registry, artifact registry. Both you will be able to see it. Let me go with container registry. Now you see it is not enabled. Makes more sense, right? It's not enabled. Now you can enable individual service by that directly going into that service and clicking on enable API. This is one way. Or you can go and click on APIs, library, search for container registry, enable it. Two different options in the UI. Go to that specific product and enable it, or go to APIs and enable it, basically. The preferred way, I would say, if you ask me, always better to come here and do it. Because I've seen some bugs. It's better to turn it here rather than going and turning it at a specific service. This is one you do. This is the way. By just clicking on this button, it's a simple thing. But why don't we do it in our command line? So to do it in the command line, I have to copy this word, container registry, or I can copy the entire thing, container registry.apis.com. So just thought as much as command line I'll inject into your mind so that you are aware of it. So let me just do this. Gcloud services enable the name of the service. Oh, sorry. Enable, it should be container registry. I did not copy it. Hope my spelling is correct. Container registry.google APIs. So let me try this one, folks. Sometimes few of them works without Google APIs short form, alias. If it does not work, I'll put googleapis.com. That's it. This is the way you enable the API in the command line. Okay, it is saying it is not existing, meaning I have to put some, they have an alias, some of them does not have, basically. Hope my spelling was correct. Let me give one more time a try. Sorry. Okay, this is not there. So the alias is not there. So I have to give it completely like this. These commands are going to be really helpful when you are building some CI/CD, like, sorry, when you're building some infrastructure as a code kind of a stuff, enabling APIs. So now let's see whether it's going to work. It should work. Done. It has been enabled. Now come to your, if you just refresh the screen, it's going to show it is enabled. In the UI, it's always easy. So I just wanted to show at least once in the terminal. It's enabled. Meaning if you just go to your GCR under your tools, I would always prefer to scroll and see it. That way you learn more stuffs, more services in GCP, and a cloud architect should be knowing at least what is that service. Service is enabled. This is enabled. Now, if I go to my IAM, this is going to be an interesting one. Let's see what are those new entries which has been added now. Still the 3 only, but if you turn this on, you should see one more entry, which was not there here. You see that 1, 2, 3, 4, 5, but here you see 6 entries. The 6th entry is container registry service agent. This is again a Google managed one. Please never ever try to touch or modify it. And the format is going to be service hyphen project number at the rate container registry.iam.gserviceaccount.com. Is this clear, folks? Every service, when you enable it, Google is going to have one Google managed service account for it. So don't ever touch it. And that's the reason they have turned this new feature, so that people, so only when they show, only people will think what is this, right? So instead of that, just hide it. Only if you are a power user, you just go and look into it. So this is what they have done basically now. Okay, so hope this is clear. Now what I will do is I'll go and build the image again and push it to our GCR. So before I push it to GCR, let me show you something as a background. Storage, Google Cloud Storage. Currently, you don't see any bucket in our batch 6 project. The reason is we have not created anything. But once we push a image into GCR, you will have a bucket here automatically created. Why? Because these images are stored in Google Cloud Storage only. And that was the reason why in the slides, it was very clearly mentioned the price of your GCR is always a price of your Google Cloud Storage bucket with some network egress cost. So it's always a multi-region bucket. I'll tell you what is multi-region bucket in storage class. So the cost is always going to be somewhat to this much. So let's go ahead and do this activity, folks. What is the one which we are going to do? The same thing is what we are going to do. We already have a Docker file. Now, instead of doing -t without any repo name, we are going to create a repo name, gcr.io dev shell project ID. That's your project ID. What is your name? This is one way if you want to build a new image with that tag. Or if you already have an existing one, you can also use a command called as, it's called as tagging. Docker tag. Usually we had like this only, right? My app. You can just tag it, re-tag it with a new repo. Once you have it, you can push it basically. So that's what we are going to do. Now, unfortunately, in our this thing, we don't have any images because we restarted our Cloud Shell. We have to build it from the scratch. So I'll just go to my where I am currently. Yeah. So what I will do now is do Docker images first. Nothing is there. Docker, Docker build. I'm lazy enough. I'm just going to use my history. Docker build -t -f -t -f. Where's my Docker file? Container of a Node.js Docker file, and the folder which I want to containerize. This is the one. The content is there, and I'm just going to do it one more time, folks, just to show you something here. Version 1, because anyway, nothing is there. I can start it with version 1. Version 1, do this. Because it's going to use Alpine, it's going to be much faster. 17 seconds, if I'm not wrong, is what we saw. very consistent. 14, 17 seconds, it is there. All good. Now, if I do Docker images, I see two images. One is provided by Node, the other one which we created. So far, so good. Now, what I will do is, if I want to push it to GCR, the repo cannot be this. The repository should be gcr.io. I have to retag it. So one way is do something like this: Docker tag, which I had mentioned there, my app version 1.0 to what? gcr.io, your project ID, dev shell / my app version 1.0. So I'm just retagging it. So when I do this, done. It is retagged, meaning if I do Docker images, I will have a new entry. This new entry has my complete repo name. I can easily push this to my GCR. This is one way. You have an image, you just retag it. The other way is you rebuild it. Docker build minus, we had it all, minus gcr.io dev shell underscore project ID underscore project ID my app I'll just call this as version 2, folks, just to differentiate it. My file is container Docker file, then the folder is this one. This is the one. This is another way where you build it. The only thing is that instead of just giving the the image name, you are giving a repository completely. So if it's some other repository, you are going to give that way. So since this is Google's, so we are going gcr.io. That's it. Now if I run this command, right, before I run this, I'll put one more tab here. This is where some concepts gets increased. So Docker images. I already see Node is there. Two more versions are there. That's it. Now, if I one more time do a build, the system is going to become smart. It already knows what is the Docker file and what is the base image. So if the base image is already pulled once, which is Node, it is already pulled. The next time when you again do some new changes to your code, the base image is not going to be again pulled from internet. So it's going to be using the cache, meaning the second time when I do the build, it's going to be less than 14 seconds. That is the key part here. So because the base image node is already there, only thing is that I'm creating a new version. So let's see how fast it's going to do. It's going to be less than 14 seconds. And you see it came everything from cache. 4 seconds, folks. Now, when I go and do Docker images, how many images do you expect to see, folks? How many entries do you expect to see? No? Yes. You will see 4 images. You will see Node. You will see this my app, which is in gcr.io version 1, my app version 1.0, another app which is 2.0. So you're going to see totally 4 because we created a new image here. We created a new image here, you see, and the image ID is ending with CC 6C. So if I just do it, it's going to show 4 entries. Hope the concept is clear, folks. Some of you mentioned 3. I guess you got little confused there. But the key part is the source image or the base image is not going to be again pulled. It's going to be the same as long as your Cloud Shell is not restarted. If your Cloud Shell gets restarted, again you have to pull it from one more time, basically. So we have version 1 and version 2. Hope it is clear, folks. I just wanted to highlight the concept of caching here. When you're building something, it's going to be a little fast, basically. Image ID is same as version, but we are given a tag, right? We are given a tag. That's a new tag we are given. So that's the reason. Okay. All right. We have our stuffs. We will just do a push. We'll just do a Docker push. Most of the time we were doing Docker pull actually. So we are pulling it from Docker Hub. First time we are pushing it to a GCR. When I push it to GCR, you would expect a bucket created automatically. Let's just see that. So if I just refresh it, nothing is there. Nothing is there. Now let me just do Docker push. Docker push to where? To your GCR. What's your version? That's it. This is the command to do a push. If you just do Docker push, you would expect you to push it to Docker Hub. If you just do Docker push. But if you have this repo in this, it understands it's not to Docker Hub, it is to Google Cloud, Google Container Registry. Let me just push it to my registry. And everything is in containers is all layers. Few layers may be already existing. Maybe Node.js, the specific version may already exist, because of which our image, when it goes to GCP, it may be smaller in size. Now let me just minimize this, go to my GCR and see whether my registry is there or not. So awesome, we have our app, my app. Host is gcr.io, visibility C. This is the most important thing, folks. By default, it's a private repo. Nothing is made public. Private repo. If I just click on it, you see just now I have uploaded it. Now, what is this icon, folks? What is this icon which you see here? What is this icon? Docker icon. That's it. It's a Docker icon. So that's very clearly mentioned there. Uh, So we have our image running. We have our image pushed to a repo. Now no need of any my Cloud Shell. So I can just start it, restart it. It's okay. It's there in one centralized repository. Now I'm going more towards that use case. Run it everywhere. Now it's somewhere in a repo, centralized repo. I can just share it with you people. You should be also able to run it. So first of all, what I will do is I will give you access to this repo. Just try to launch it and see whether it's going to work in your Cloud Shell. Let me see first from my Cloud Shell, will it run in your Cloud Shell is what we are going to do as a small activity. So please launch your Cloud Shell, keep it ready. I'm going to give you the command to pull it in your this thing. Because it's currently a private one, what I will do is I'll change the visibility. I'll change the visibility. And before I change the visibility, I wanted to show you the bucket. If I just refresh it, currently it is empty. If I refresh it, I would see something, artifacts dot your project id dot appspot.com. It is a multi-region storage class. Now, if I go inside this, I'll see a folder called containers, and all the binary versions of those details would be there. Anil B was asking, how can I see the content, all those things? You can just see those binary versions here. Download it, unzip it, you should be able to see it. If you want to see it in your container registry. If you were to see it in your Cloud Shell, you can go to that location, basically. So a bucket gets created automatically when you turn on your, when you push something to your container registry. Now,
Because it is public, because it is private, all your objects are also going to be private only here. Public access will not be there. So these are all private images. See, it is all private. Now, when I want to share this with somebody, I wanted to share it with, say, for example, one person. I don't have that capability, folks. I don't have any option. No info panel, no nothing. Not like your virtual machine stuffs. You see, there's no option for me to share it with a specific person, a specific identity. It becomes very difficult outside. So it becomes very difficult here. So this is one of the drawbacks of your container registry. That is what they had mentioned why artifact registry came up. So in artifact registry, you will have access to, you can give granular access, but here it is not possible. So now how should I give you access then? Simple, I'll make this repo public. So go to my settings, visibility, public. Everybody should be able to see it. Now if I go to my image, it is public. Now if I go to my bucket, because that's where it is all hosted, if I just refresh it, all these things are going to become public now. See, everything is public. Now it's a public image. Let me give you the URL so that you can pull it in your Cloud Shell, folks. We'll just do this activity and stop it for today. So the command to pull it, I can get it by when clicking on that image. Show the pull command. So this is the command which you have to use. Please launch your Cloud Shell, go and pull this and let me know whether it's working. Pull this, folks. Pull this and type Docker images. Before pulling it, just try Docker images. Nothing should be there. After pulling it, you should be able to see an image. I'm just going to restart my Cloud Shell so that I can also try it, basically. Any success, let me know, folks. Anybody able to pull it? Done. So do you see Docker images, Mangesh? If you put, you see that. So first time, people, you just try something like this. Docker images, nothing is going to be there. Then use the command which I gave, pull it. It's going to pull from my repo. Once you have done it, do Docker images. Awesome, Vivek. You see the image. What is left over? If you have pulled it, what's the next step, folks? Try it. Please try it whether it's going to run in your Cloud Shell or not. Let's do a try. So how do I do it? Simple. Use my Docker run command. Docker run -d -p. Which port you want, you run it. And the image is this one. Okay, able to pull it. Anil B is having issue. Let me just see it. 1 minute. Awesome, folks. It's coming. Very good. Now, the way you execute the command, run it, is using this. Just try running it, folks. It should get executed. If you put Docker process, you should be all there, and just do a preview. Just do a preview and see whether it works. Let me know whether you are able to see a preview. We'll stop it here. I'll just help you out if you are having issues. Let me see whether it works. My wish has come to some extent true. It is running in somebody's machine. So it's running in your Cloud Shell. So at least to some extent, we have achieved it. Now let me stop here. People who are having issues, let me know. Awesome, Mangesh. If it's working, the last thing which I would expect is you do a preview and see it in your own browser, folks. In your own browser. You go look into your own browser and see what is there. Is it showing up? So if it's working, all good, folks. If it's not working, let me know. Anil B, you are able to fix that? Some invalidate. Do I need to enable API for content? Nothing. You don't need to do anything in your project, folks. You don't need to do anything. You just need to have a cloud shell, nothing else, which comes free. Which comes free. So port, what is the port I'm running on? You can run it on any port. You can run it on any port, Kumar. So the command which I gave was on 8090. So you have to change the port to 8090. Change the port to 8090 and try. If you have tried the same command which I gave, 8090, you do it and do it. So Anil, just try restarting your cloud shell and see it once it works. Awesome. Could not connect. Okay. Kumar, just type. No. Deepak, if you share your link, it will not work for me. It's not going to work for me because it's only to you. Uh, do this. Kumar, try doing Docker PS and see what is the port on which it is doing the forwarding. Use that port and preview it, Kumar. Docker process should show you the output basically. I'll just wait for a minute, 5 minutes here so that I can fix anybody's issues. Try it, folks. I have a hard stop at 10:10. I'll stop it. Worked. Same issue. Okay. Not showing anything. So Kumar and Anil has issues. Post restart also it's not showing. Okay. So okay. First of all, so what does it show when you type Docker images, folks? Kumar and Anil B. Empty. For Kumar, is it empty? Kumar, is it empty for you? It is showing. So meaning at least you have pulled in the image. Anil, if you use this command, what is happening? It shows an error. Okay, Anil, can you just try this one? Docker -- images. Docker -- version, sorry. What does it show? So for Kumar, it is all good. So Kumar, you can try something this one. Try this one, Kumar, in your this thing, and let's see what happens. Docker is there, but when you pull, you are getting an error, right? When you pull, you get an error. And what's the error specifically? Sorry, I missed it. What was that? What's the error which you get? Folks, we have stopped it. We have stopped the class. We have stopped the class. And if you don't have any questions, you can drop off. Okay, Kumar, then it is running now. One question, Kubernetes deprecating Docker as container after. One question is deprecating Docker. Yeah, I heard something. They are going to go with something else with a different container runtime called as container D, something like that. Something of that sort is what I have also heard. Not fully confirmed, but I have heard something like this, Vijay. So Kumar, port 8080. Now just do a preview. If you're running on some on your corporate firewall rule or something, it may not work, Kumar. If you are running on that kind of a device, it may not work. But just give a try. The simplest one which you can do in your this thing itself is local curl HTTP local host. If you run with some this thing, at least this should work. It's a personal one, then it should not have any issues. Just give a try. At least this one should work.
Mangesh here.
Invalid reference format. Very strange.
Mahesh, am I audible? Mangesh here.
That's it, Kumar. That's working. It's working for you. So it's only Anil B is having issue. Restart done. This thing done. Invalid. Okay, invalid reference.
Mangesh here. Am I audible?
Reference format. I'll also check that. What is that? Maybe what's that? I'll check it out. I'll let you know what is the issue there. So no, Mangesh, you're not audible. Oh, okay. One minute. I guess there's some issue with my this thing. Just give me a minute. 1 minute, folks. Maybe my audio. Mangesh, can you start? 1 minute. Now, can you talk, please?
Is it audible now?
I'm not hearing it. No, 1 minute. I guess I have some issue with my headphone. 1 minute. Okay, no, I have an issue with my headphone. I had an issue.
Hello.
Mangesh, is it possible for you to type it? I don't know what's the issue with my side. I'm not able to hear you people. I see there's an issue with my headphone. If you can type it, it's going to be good. Is that a question you have? Let me know. Actually, I heard a couple of things got deprecated in. I'll check it out, Vijay. I have not looked into the things. Few things are changing, is what I know, but I have not. I don't have a complete picture. So, Mangesh, still after having external IP not reachable, I have installed Apache 2. Okay, Vijay, you can put it in the entire chat so that everybody is going to be helpful. So that was a very useful information. It's private. If you can put it to everybody, it's going to be helpful. Okay, for Mangesh, it's not working. Okay, what I can do is, Mangesh, it's basically you. Okay, let's do this, Mangesh. Try something like this. Let's go together and you can do it. So if you can, thanks Vijay for that. So that's the newest version. So create a VM, Mangesh. Create a VM with this, it's going to work. So VM, leave everything default, don't do any changes. Come to your firewall rule, turn on HTTP. Let me know once you have done this. Turn HTTP firewall, that's it. If that is done, under your startup script, just add 2 lines, apt update and apt install -y Apache 2. Just do these 2 things. That's it. Let me know once you have done these 2 things. Firewall opened, done, firewall checked, and the startup script. That's it. If it's done, just click on create. Just click on create. Let me know the virtual machine is provisioned or not. For me, it is provisioned just now. You should have a hyperlink because of that firewall rule. If you click on it, maybe the first time it may throw an error, but next time when you refresh it, it should show up. It's working for me. It's working for me. Let me know, Mangesh. This is the one which is my IP. If it is blocked at your this thing, just ping the IP. I'll check it from my side. It should not have taken this time. To share the screen, okay, first is the hyperlink showing. To share the screen, I have to do some settings because of my phone not working. It will be difficult. Yeah, Vijay, you can drop off. Okay, let me just see the IP address. Do you see an hyperlink, folk? This thing in front of you, with Mangesh, there's an hyperlink, right? Okay, okay. If you are seeing it, then it's going to work. It is working. So it's because of your corporate firewall rule. If you're using an office laptop, it may be not working. Open it in your phone, it's going to work. Because it's non-HTTPS. Your corporate may not allow. Personal laptop, can you open this link in your phone? Can you open this link in your phone? Open your this thing, it should work. It is working for me. It's working for me. It's only something. Okay, it worked. Okay, it took time. Okay. Okay. It usually takes, the startup script will take time. That's it. All right, folks, we'll stop it here. I also have a hard stop. Oh, command was wrong. No problem. So make mistakes, only then you will learn it. Okay. So we'll stop it here, folks. Tomorrow when we resume back, we will look into running it in a virtual machine. Okay. So we'll see how to run it in a virtual machine and all. We'll see it tomorrow. We'll stop it now. I'll send you the recordings and I'll also upload the updated document by end of day today. All right. Thank you. We'll see you tomorrow, folks. Thank you. Bye.